Hey guys, welcome to the session by K21Academy. In this session, we will be learning about Docker comprehensively. Now let us take a quick glance at the agenda. Firstly, we will be getting introduced to history of application deployment, where we will be focusing on monolithic architecture, microservices architecture, and then containers. Post that, we will be trying to understand the difference between containers and virtual machines. And then we will see why do we need Docker. Post that, we will try to understand the Docker architecture. And then we will see how to install Docker, where we will be focusing on how do we register a free Azure trial account. And then we will see how to create and configure Ubuntu machine on Azure cloud. Also, we will see how to connect Azure Ubuntu machine from Mac. And then we will also focus on how to install and configure Docker on Ubuntu machine. Post that, we will try to understand more about Docker daemon and client. And then we will have a brief session on Docker images and DockerHub. Post that, we will be getting introduced to Docker Lifecycle. And then we will have a tutorial session on Docker commands. Post that, we will understand more about Docker networking, where we will focus on bridge networking, custom bridge and host networking. And then finally we will learn about Docker storage, where we will be focusing on host path mounting, volume and TMPFS. So we have taken a clip from one of our certification training program on Docker and Certified Kubernetes Administrator, which is CKA. And in this clip, our expert will talk about Docker comprehensively.
In the era, in the past 5-10 years behind, if any of the applications you people were browsing and if it was not working, then what used to happen? It used to be page 404, and that used to be a very common thing, right? It was page 404 used to be a very common thing, because if some components are not working, rest everything also stops responding. Why? Because it was behaving like a single unit, the complete monolithic application. When I say it is a monolithic application, it's a big bulky application in which the front end, the middleware, the back end, everything is there, and they are behaving as a complete unit. Okay, if you are bringing up a complete application, like for example a complete website with a backend, with a caching layer or something like that, everything would be a single component. If you have to deploy, you have to deploy all the components. If you want to make any changes to the, say, website, you can't just deploy your website, rather everything has to be redeployed. So such type of applications are called as monolithic applications, and these applications were built around 8 or 10 years back. Whatever applications were built, they were all monolithic type of applications. Okay, and the basic three main components, which is the user interface, the database, and the backend, everything would be together as a single unit. And we would see this way, like you have the business logics, you have defined the logics into small blocks, but they would work only when they are sitting together, and you have tightly coupled them. That means if I make change to this particular logic, I would have to redeploy everything, and I have a database associated with it, I have a front end associated with it. So what I'm doing, if anything is going wrong, I'll have to recompile everything, rebuild everything, redeploy everything. So in that case, what happens? It becomes a big tedious job, right? Just imagine Mamta is working on block 1, the circle 1 business logic, and Atul works on logic 2. If Atul is making any changes to the logic 2, this particular application, mini application which is there, then in that case, Atul has to recompile everything and redeploy everything and then check whether his logic works or not. So it takes hours together to build this, to deploy this, to bring up the application, and then know whether it is working or not. And this is the monolithic type of architecture. There are a lot of disadvantages associated with it. With time, when the application grows, the complexity is growing, and it's not 100, 200, 300 lines of code. I'm talking about some 10,000, 20,000 lines of code. So I correlate to this so much, and why I said that I've fallen in love with microservices, Kubernetes, and containers, because I come from the era where I've seen the pain of monolithic application. You guys are using phones, you make calls. I was in the 3G, 2.5G, 2G technology working for AT&T, where we were building the complete protocol stack from where the call would flow through, right? And you won't imagine, our files used to be 10K lines of code, and if an emergency call gets dropped, we used to pay fine for it to AT&T, and you get charged for it. Okay, in US and all, it's not. In India, if there is an emergency call drop, no one gets bothered about it, but it's not the case in other countries, right? In such places, if there is an emergency call drop, you get charged for it. You're answerable for that, right? So in such places, finding out what was the root cause for it, it's very difficult if your lines of code is 10,000 lines of code. And if you have to make any single change, you have to redeploy it and test it, and then you think, oh shit, it doesn't work anymore. That fix is not the fix which I expected to fix this particular issue, right? In such cases, monolithic applications had a very huge drawback. We were not able to figure out changes pretty quick. In case you have to implement a new feature, then you have to touch across a lot of logics, and which is getting affected. You can't estimate or judge that, because they are so tightly coupled that if you make a single change, it has been having a lot of effects in a lot of places, and then we end up testing the entire system. If you say a developer needs to test any change, then he has to work with the entire system, test everything. So in such cases, adapting new technologies would affect the complete entire system, and this takes a longer time to build, to test, to deploy. Everything becomes huge, and we can't think of having DevOps, we can't think of having a CI/CD pipeline in which I'm building every day, right? I remember in 2005-2006 timeframe, we used to build in 1.5 months, and 1.5 months, 300 team people, out of which 200 people are developer. On a daily basis, when they are checking in their code and you build after 1.5 months, there's a huge set of code which is there, right? And you don't know which code line of code has affected the which other line of code. So we are talking about an application which would look like this. Everyone is booking a cab using the mobile apps. If something is not working, you never realize that it's not able to scan for the driver. It shows us rotating and scanning, but at the back end, it could be that the scanning service is not at all responding. Or I could give a better example, like everyone would be shopping in Amazon.com, right? And when you are opening the page of Amazon.com, it's just not a single monolithic application which is bringing up that page. That single application is served by more than 70 containers at the backend. That means 70 microservices running. Like if you want to categorize, product overview is a microservice which is running in one container. Customer review is an application, mini application, microservice running in one container. Billing is one application running in one container. At the side, it comes right at the right hand side, what you saw last time, few people what they saw when they saw this product, all those things. So it comes up with, it's built up of multiple microservices, and if one thing is not working, you would not realize that something has gone wrong. Okay, so same way, if I have a monolithic type of architecture, and even though I have separate logic implemented, but it is sitting inside one hexagonal block, and this is a way of representing a service. Okay, so this is a complete service, and they together form the complete application, and that's the reason it is called as a monolithic architecture, because they are so interdependent on each other. If I remove this and I say it would run on a separate machine, and will my application come up? It will not. It will sit down. It will not work at all, because it can't digest the latency of talking to other service, from billing to passenger management to the billing. The latency of the packet going and coming can't be digested by these applications. Okay, the mini applications which are running. So here, if you see in the monolithic application, You can do integration with third-party services, right? Like Stripe is for the payment gateway type of thing. You have the web interface with which you can interact with these applications. You have the passenger way of interacting it. You have the driver way of interacting. And the biggest drawback was you see a single database serving the complete application. And if this database goes down, it's gone. Nothing is up and running. And that's the reason in that era, we used to see a lot of issues with related to page 404, stack completely going down, and things not working, right? So what are the effects of it? If the application size of the application is big, obviously there is a slower development because you have to judge where all it would be affecting. You have to invest a lot of time in judging what all changes has to be done because it's a tightly coupled architecture. And when you are building up a larger application, the startup time, the deployment time, all those things are very huge. And when we want to do a continuous deployment, it becomes a bottleneck at that case, because if my building and deploying itself is taking me 2 hours, I can't say it is a continuous deployment. It's a joke then, right? And the testing has to be extensive because it can affect, adverse effect can be on any of the modules. And when you want to scale, here, if you see in this, a lot of people are scanning for the cab, but very few people are actually booking for the cab, right? If I just want to scale the scanning application so that it can serve a lot of traffic, and I know that 10,000 people scanning, 5,000 people booking, then the load on the server for 10,000 requests is much more than the 5,000 which is coming, right? If I just want to scale the scanning application, I can't do that with monolithic, because if it scales all the bits and pieces, whatever, every block will scale in the same ratio. So scaling is very difficult in that case, and it's very difficult that you have different loads and different modules, then the scalability can't be handled at all. And if you want to implement one module is best fit for these days, you would have seen that the application, when they are built for the website, Node.js, React.js, a lot of different languages have come up. If I want to adapt those languages for some of my modules, I can't do that. The complete framework, the complete language has to be common across every module which is forming my monolithic application. I can't say for this I'll use a NoSQL database and for the other I'll use a SQL database. No, that is not an option. Okay, so because of such things, monolithic was a big pain for us, and then we thought what should be the solution, and we moved in the era where we thought that we have to make something which has to be highly scalable, easily maintainable, easily testable. It should not have the tightly coupled architecture, and it should not be interdependent so much. If I make change to a module, I should be able to deploy that module and test it. It should not be the complete redeployment of the complete application stack, right? And we would see such examples when we are doing Docker labs. We would see if I make one single change, I need not bring up the complete stack. I'm just making changes to the front end. I'll just redeploy my front end. I'm making changes to my back end. I'll just redeploy my back end. Okay. So here it's called as a 2 pizza team type of technology. Okay, wherein you get 2 pizza, and if you're able to serve your team, that means you're building up microservice. Then you can understand that your team is sufficient enough to serve that mini sort of application, a single module. And there are a lot of challenges as well with respect to that, bringing up those microservices, working them together and all. We would focus on that as well. But the beauty is we would not see that page 404 or application stack completely going down. Just imagine if traffic is running and my complete stack goes down and it takes me 15 minutes to redeploy it, my 15 minutes traffic is gone for a toss, right? People are not able to reach my application for 15 minutes. It's a big, huge loss for a company which is not able to serve for 15 minutes. We can't live in that era. For 5 minutes, if something goes off. Like if I want to watch a movie in Netflix and it's not working, I go and post in n number of social media, Netflix is not working, then it's completely clashed, that the image is gone for that company, right? So we can't live in that era. So that's the reason we would have to shift our way of designing the things, and how do we deploy them, how do we manage them, how do we work with them, so that these issues which are there, not able to scale, not able to heal, not able to deploy, test, and build separately, those has to be fixed. So monolithic is one of the thing. It is like a giant ball of thing. It's like a big dinosaur, which is very difficult to handle. So we would break them into pieces and we will work with microservices. So everyone is using microservices, okay? Everyone. And in this lockdown era with Corona, everyone is crazy about Netflix. People are shopping on Amazon, Myntra, any website you say these days, or you're playing games, any games which are running like Pokemon Go, any type of application you can talk about, I would say it's working on microservices, okay? And Netflix was one of the biggest or earliest adopters of microservices, and everything you see over there is running in containers. So now I think you people can correlate how exactly it works, right? It's so beautiful. If you open up and it gives you what screen you are seeing, I am not seeing the same screen. It prepares the screen, or it prepares the complete page according to how Mamta wants to use it, right? First time everyone is getting the same page. From next time onwards, if I have seen a web series related to history, next time it will give me a very similar type of option, because it understands my taste. I understand machine learning is there behind it, but everything is running in containers. Let it be a machine learning application, let it be Netflix application which is serving the video, let it be a application which is saving your reviews over there. So lot of microservices are running to make that complete Netflix type of application, right? So I'll just quote an example. Like, for example, I want to buy a blue shirt, okay? I want to buy a blue Alan Solly shirt, and I go to Amazon.com and I look for the blue Alan Solly shirt and find it. And I just want to check the customer review over there. Then if I scroll down, I don't see any stars over there, no rating is there. So I just scroll down and I verify, I don't see any customer review. So what I estimate, I judge that, okay, maybe people have bought this shirt and that they have not reviewed it, okay? I add that to the cart and I just don't buy it that day. I'm busy with some other work and I don't buy it that way. Next day, I think, okay, let me pay and buy that shirt. And I again go and just check the product description, thinking if I have missed out anything. So if I click on that, and today I see there are 30 customer reviews. How is that possible? Yesterday there was not even a single customer review, and today there are 30 customer reviews. It can be possible because when the complete web page for the blue shirt came into picture, that time a single small service of customer review didn't respond on time. And because it didn't respond on time, it didn't say page 404. Rather, what it did, I mentioned some time back, when we are talking about containers and containers are born to die, we don't want to build an application thinking that it will never go down. We think our mentality or our understanding or our thought of building an application should be that we would build an application which can digest any such failures, and we understand if something is failing, how to handle that. So our focus would be to handle disaster recovery, to handle if we are unable to not scale up that quick, or if something is not working, how to handle that. So how they handle this customer review not working, they would not show up that customer review section over there. Rather, they would say, whoever saw this Alan Solly shirt also saw this Van Heusen's shirt, also saw this H&M shirt, any other brand they would say. Or they would show whoever saw this blue shirt also looked into other blue shirts. You want to look into other blue shirts or other Alan Solly shirts. They give something apart from that. And you don't realize, I don't realize the first day that the customer review is not there. And next day when I go, I think, okay, how come 30 customer reviews? It is possible because we are in the microservices era. If something is not working, that has been replaced by something else which is working, and that makes sense on that page. Okay, I'm not upset that it didn't show me customer review. It gave me many more options. It showed me much more options. Maybe I was just looking for Alan Solly shirt, and later I realized some other brand is much more better than that, right? So people don't get upset about it, and they digest that error. You don't even realize, being a normal Amazon user, you would never realize that page not loading type of thing or page not found type of thing, errors will not be there. So in such cases, whenever you are coming to the landing pages of such applications, whenever you are making any application which has multiple logics behind it, billing logic, payment logic, customer review type of logic, scanning type of logic for anything, or have a lot of other logics, we are in the era in which we have to understand where to draw the line for each mini type of application and say, now it is self-sufficient enough to work and it is not dependent on any other any other services. Okay, so that is called as microservice. Like I'll just go down to this. So we saw the monolithic way of architecture, and this is the microservices architecture. In this, passenger management is having its own hexagonal block. It will open up its APIs. You can call, if passenger web UI wants to talk to passenger management, a single call will go. I am least bothered. It is sitting on the same machine. It is sitting on a different server. It would be completely different. So this is a microservice running in a container. This is a microservice running in a container. When you scan as a passenger and there is a driver management happening, there is a trip management happening for me, then just a call from the passenger's web UI goes and it shows up this page. And we don't realize this is a separate page or separate service serving us, right? Because we think this is a complete set of application altogether. So here, trip management, driver management, payment, billing, name anything which is a logical block, that is like a microservice for us. Okay, so all billing things, whether you are purchasing, you're booking a corporate cab, you're booking a cab for an individual, whether you're booking a small cab, whether you're booking a big cab, billing remains the same, right? So everyone will just call the API after the trip ends, and this logic is no more associated with any other blocks. It can standalone work. If I make any changes, like instead of Stripe, I say I would be integrating with PayPal, then in that point in time, I would not have to deploy all these things and check whether my PayPal payment is working or not, because I know what sort of call the trip management will make, and I'll just make that dummy call and I'll just test if my integration with PayPal is working or not. Okay, so this is how we build up microservices, and why we are talking about microservices in Docker or Kubernetes class. That is one question, right? We are talking about microservices in Docker Kubernetes class because when these applications are small enough and you run them in virtual machines, they don't utilize that much of resources. Your rest of the machine is waste. The resources are wasting on that. So when they are small, you build small, you deploy small, you test small, then you bring up small in smaller set of blocks, right? So we would be deploying them in containers so that we have better resource utilization, the deployment is quicker, the testing is quicker. We would see what all advantages container as a technology brings to us, right? So if we are designing microservices, we will think that we would have separate logic separated completely. The front-end logic is also broken into multiple things. I had in the previous one, I didn't had a separate web UI for passenger and the driver, right? Now the APIs have been different, and whoever wants to log in, they have a different logic altogether. If I'm implementing some changes for the passengers, I did not test the driver page, because here there is lot of changes which happens, then it is only affecting this, and a call going from these microservices to other microservices we should be bothered about. We would not sit and test everything. So that's the reason here we would be discussing how to open up these APIs so that the other service can talk to us, and how to make them sit in different servers, yet we should not have the adverse effect or a bad effect that they are unable to communicate, right? So we would see how does the communication would be set up, how we would digest the latency of the packet, how we would implement retries into picture. A lot of things are there which helps us design this microservices in a way so that we can make it as a robust architecture. And something is failing, then also we are not failing completely. We are still able to serve the traffic, and we are not saying that it's completely down. So we don't believe in going down completely. Rather, we believe if some things here and there are breaking, how to make that up and how to serve the traffic at any point in time. Okay. So if you see, now we would be deploying things in containers. So trip management would be running as a Docker container. And if I want to scale the trip management, because when a lot of trips are happening, then I want to scale the trip management. I can individually scale one service, and I can put a load balancer in front of it so that it can balance the load across multiple replicas of trip management. And when we are doing trip management, obviously there should be a database associated with it. I would have individual databases attached to it. Okay, so just don't think if it is too much for you, hold on, don't get overwhelmed, don't get anxious about it. Like Mamta is speaking so many terminologies, we would have separate databases, how it will work. We will make everything work. We will do the things in the lab, and we will see everything in practical. Today we are just doing the theory part of it, and we have 7 more weeks to go or 8 more weeks to go, in which we'll make them work, and we will deploy applications, and we will have separate databases so that they can talk to each other. And you will have a question, when they were sitting together, then they were not having a good database. Now when they are sitting apart, how can you guarantee they would work together, right? Then better databases are there, distributed databases are there, and they make everything work together. You feel it's a single database, but at the back end it's completely distributed, and we can handle the synchronization and all that stuff and make them better, work better, right? So lot of things we would be discussing about. We would be discussing about how the application will have their individual databases, how we have a gateway type of service wherein we can route packets to different services. I'm just running through these slides. These are just keywords which we would be discussing. Don't go through the text. Rather, we would be, when we would be implementing these stuffs, I'll touch through each of the points and I'll tell what is an API gateway. Now understand, if I have to route my packet to multiple services, like I'm serving multiple stuffs, right? You are having Amazon.com, but you have Amazon.com/Black Friday sale, right? Then how does it serve that? So we would have an API gateway which has the intelligence to route the packet by opening the packet and seeing where exactly it has to get routed. We would see that. And when we are running things in container and we don't have persistent memory, when we don't have persistent IP addresses, we would talk about how to discover them, where they are running, what is the present IP address. That becomes a bigger challenge. That point in time, we would be talking about service discovery. And we have to discover the service. We have different ways of discovering the service. We would be running through them as well when we do Kubernetes. And if we are trying to discover, there should be a database which has to keep a note what is running where and what is the present IP address. Then in that case, we would be talking about registry, where we would be maintaining the complete data, because I'm not running one application and having one IP address now. I am running into different blocks. I have 10 blocks instead of one, and everyone has an IP address, and that IP address is not static. So I will have to maintain a database, which is like a registry, in which you would say what is running where. Netflix donated a open source code called as Eureka, with which it manages all the internet working across microservices. And we would be dealing with etcd, which is a part of Kubernetes, and we would be deploying these and learning how to work with them. Okay, so we would be doing these stuffs, and we would be talking about deployment strategies in which we would be deploying them in containers. So we would be deploying virtual machines and we would be deploying these applications in containers using container images, and we would be reaching those services. So we would be choosing the most popular way of deploying microservices, which is container pattern, and we would be talking about how do we deploy these containers. Okay, so microservices, when we are saying, example, the Ola type of service, any cab booking service, Uber type of service, Netflix, those are example of microservices. And when you say microservice, as we showed that the driver management is a microservice, the billing is a microservice, the payment collection is a microservice, the trip management is a microservice. That itself is an example of microservice.
We would discuss about introduction to containers. So let's first understand how a virtual machine works, and on the same piece of hardware, we are able to run several machines. So you have the hardware, let it be either in on-prem or cloud, and on top of it, there is a software which is called as hypervisor, which has the capability to virtualize the complete hardware, which is the underlying infrastructure. On that particular hardware, I am able to run several machines. But when you are taking a virtual machine, it has a full-fledged operating system, which is addressed as guest operating system. We have the libraries and binaries which the application would need, and on top of it, the application runs. So when we have a virtual machine, it would be using the complete stack, the application, the binaries, and the guest operating system. If I have to run another virtual machine in the same piece of hardware, I install one more copy of operating system, and I have binaries and libraries for a different set of application, and I can run multiple services or the mini applications which we have, like the front end and the middle tier type of application breakup, I can run inside that virtual machine. So here, if you see, when I'm packaging a virtual machine, this particular package is pretty bulky because it takes the guest operating system along with it in the package. And in case I want to package the other virtual machine, I will have to package the green stack completely together. So let's understand how does this virtual machine, you made our life simple when we compare to the physical servers, but it still had an issue with it, a bottleneck, which we have removed, and that is the reason containers have become more popular, right? So virtualization was done on the hardware level based. Hardware could be virtualized, but we had a dedicated operating system for each of the virtual machines, and that was the major block of code which was residing, right? The virtual machine's guest operating system is very bulky. If you take RHEL 7.3 type example, it would be 7 to 8 GB. And when I'm saying a guest operating system runs, the processes of the operating system would be eating CPU cycles, resources, memory, and all that stuff, right? So due to that, it becomes very bulky. And when we start up, it takes a lot of time to start because the guest operating system initialization time plus the application initialization time becomes the complete VM initialization. And in case I am running a web server type of application inside a virtual machine and I want to scale it up immediately because there is a high demand, it takes a while, 2 to 3 minutes to spin that machine and initialize the application and start serving. So in those cases, we have a drawback. Initial dynamic scaling is a bit delayed. And in case we are packaging, if I want to take a snapshot of the virtual machine, it would be snapshot of complete this yellow stack or the green stack, right? So if I want to pass on the image to my test team, for example, 7 to 8 GB is the size of the guest operating system. And then, for example, if we consider 3 GB to be the size of the application and binaries, then totally I have to create an image whose size would be 11 GB in size, right? 11 to 12 GBs in size. And that becomes a pretty bulky type of image. So in case of containers and in case of virtual machines, if we want to compare, here in case of virtual machines, utilization is not that much improved when we try to compare with physical servers. In physical servers, if I have a server, I want to run an application, it's fine. But when I had to run multiple applications that time, because I was not able to isolate those applications, it was a challenge for us, right? And when virtual machine came into the IT industry, people adapted that because we could isolate the virtual machines in their own environment and they would not trouble each other. They get dedicated resources and not trouble each other. But because of the guest operating system, which was the full-fledged operating system, the utilization was yet not improved that much. And in case of containers, here if you see, we just have the libraries and binaries and we don't have the full-fledged operating system. So the utilization is not that much. These are the empty resources present. Same way, if you see the size of a virtual machine is much, much higher. It's in terms of GBs, wherein the size of a container is much more smaller, say in terms of MBs. And in case the boot up time, if you want to consider, the boot up time in virtual machines is much higher than the boot up time of a container. Container spins up in millisecond time frame because it doesn't have a full-fledged operating system. So these were few of the advantages when we are comparing the virtual machine to any sort of container. Here we have taken the example of Docker container, but that could be the case with any other container as well. Let it be a Linux container, let it be a RKT container, any sort of container. One more big drawback I can think of virtual machine is in case you are running an application, you can't make that application completely abstracted or not dependent on the environment in which it is running. If it is running on a specific operating system, I can't detach all the settings of that particular virtual machine from there. And that is the reason if we pass on the image from one environment to the other in case of virtual machine, still then it will not run as it had run in the previous environment. Some dependencies and some settings has to be redefined again. But in case of containers, if we say we are taking a snapshot, which is called as image in the world of containers, it captures all the dependencies, all the environment variables, everything all together in the same package. And we would be able to run a container in any environment if it has executed in another environment altogether. So that's the comparison of containers and virtual machines. Let's see how does the stack look like. I have the hardware and on top of it you install the operating system, and this host operating system would be shared across all the containers. An application gets decoupled from the operating system because of the containerization platform. Like in our case, the example of containerization platform is Docker. So Docker decouples the application from the operating system. And if you see the application, it is just application plus the binaries and libraries which are needed for the application to run. But application can't spin up or can't execute without an operating system, right? So there is a thin layer of operating system running underneath. So your container has a very thin layer of operating system. Like in case of virtual machine, we took the example of 7 to 8 GB size of RHEL7. The same way, if we take container image of an operating system, it will be just in MBs. Like RHEL7 image would be max to max 40 to 45 MB in size. So what happened when we came into the era of containers? They stripped off all the processes which were not needed to execute an application inside a container. It just provides the file system and the boot up resources to the application so that my application can boot up. And in case you want to run multiple containers, you can go ahead and execute it this way. And service A would be one container and service B would be one container. And we can even share the libraries and binaries across containers. And if I want to package my application one container, it would be just the application package plus that operating system, which is called as the base layer or base operating system with which my container comes up, the 40 to 45 MB operating system slice, along with the application. And in case I'm packaging service A as a container, I can package it along with the binaries and libraries. And when I want to package the service B as a container application, then I can package it separately as well. But when it runs in a machine, it shares those binaries and libraries. And this helps us in utilizing the resources in a much better way because we are sharing the libraries and binaries across containers. So when we talk about containers, containers are lightweight because they don't have that extra load of the hypervisor. They don't have a full-fledged guest operating system. They directly run on the host machine's kernel. So Docker software or any containerization platform helps to run container directly on the host operating system, as we saw. And you can even run Docker containers within virtual machines. So in the cloud, when we don't get bare metal and we get a virtual machine, we install Docker inside the virtual machine and we run containers in those virtual machines. So that way also it is possible. We would use containers to develop our application and all its supporting components. So everything would be running inside a container. We would be working on microservice type of architecture, wherein each microservice is a standalone container and they would be working together. So container would be our basic unit of the block, the basic building block for distributing or testing, whatever you want to do with the application, either develop, deploy, test, everything can be done in containers. We would discuss about the Docker overview. So what exactly is Docker? We understood that Dockers are very similar to virtual machine and they have those isolation capabilities and all. And in case you have any containerization platform running, you can run applications in container. So you should have the Docker software up and running over on a machine and you can package your application as container. And in case you want to run several applications or in a containerized environment on one machine, you can even do that. And that is the reason we say the utilization has improved drastically, because in one set of hardware, if I can run 3 virtual machines in the same set of hardware, you would be able to run more than 10-15 containers. So in this Docker machine, I want to run several applications. I package them as containers. They are isolated, they are secured, and they are happy running on the same piece of hardware as well. They don't trouble each other and they are completely isolated. We will see how this isolation is also attained. Let's first understand what all features does Docker container provides. So it provides isolation and security management. We can run containers and we can run several applications inside containers. We can have simplified way of configuring those applications because they are no more dependent on the environment in which it is running. It is much more simpler to configure your application. We can increase our productivity. Why? Because when we are packaging microservices or any application inside a container, it is very smaller in size and it can be individually developed, tested, and deployed. And we go along with the saying of Agile, which is the minimal viable product, right? We try to develop small, short things which can be developed, tested, and deployed separately. And each time we are upgrading from one version of the container to the other, I need not bring up the complete stack. And if I want to do the CI/CD, I works well with containers as well. You have tools just to do CI/CD, continuous integration and deployment with the help of containers. Plus, that increases rapidly the deployment process. We can go quicker time to market. There would be a shorter time to market, and we can release different software versions or features pretty quick because we are working with containers. What all industries are using Docker? All industries, I would say, are using Docker. Let it be aviation, let it be information technology, let it be healthcare, let it be finance, let it be telecommunication. Name the domain, and containers or Docker is already used by that particular domain. So these all industries already use containers, and containers are even running in production. People have an assumption that containers are not secure, containers are not stable, they get killed pretty easily, but we have fixes for those drawbacks of containers. So containers are up and running in environment of production as well, but we would need a management layer on top of it, like for example Kubernetes, to get that in working condition in the high available, highly scalable, highly healable way. We would learn about the introduction to Docker. So let's understand how we have to work with Docker and all the small bits and pieces, how it is created, how it works on top of an operating system, how does it interact with the operating system, from where does it get the resources and all that stuff. So Docker provides us a platform to developers, to sysadmin, to any testers, everyone, for developing, shipping, and running an application using containers. So with the help of Docker, we can quickly assemble all the components and eliminate that friction. What do we mean by eliminating the friction? When we are running microservices which are interdependent, which work along each other, which has to work with each other in separate containers, there could be a latency, there could be different sort of function calls which has to go through. In those cases, containers helps us design that in a better way and makes us run those multi-application stack together as well and ship it together. So that's the beauty of Docker or any sort of containerization platform. Docker helps to be used by testers as well to deploy the code in production. We can use automation tools which can help us create containers and run that in production environment as well. What functionalities does it provide? As we mentioned, we can develop our application and supporting components using containers. We can test the application using containers, and finally we can deploy the application using containers. And if we want to orchestrate or have automation on top of it, then we can use any of the orchestration service like Kubernetes or Docker Swarm. What underlying technologies are used so that we attain isolation and containers are up and running in the same piece of hardware without interfering with each other? So namespace is the one which provides the layer of isolation. It's the same funda which is there behind virtual machines as well. So namespace is a kernel feature, operating system's kernel feature, which helps us attain isolation across containers. So if I'm running multiple containers, they would be isolated in their own environment. There would be a space created for them, and it is like that it would have a box name for it, and everything related to that container would be contained inside that box. That's the reason it is called as namespace. So it is getting a isolated workspace which is called as the container, and Docker would create this namespace for the container. How does Docker has the ability to create? When we say Docker creates, Docker talks to the operating system level and creates a namespace on the operating system level for the container processes to execute inside that namespace. Docker engine uses namespace such as it already has a process namespace for the process isolation, network namespace for the network isolation, Inter-process communication, when it happens when one process communicates to the other. In that case, it has the IPC namespace. For mounting any file system, it has a mount point namespace. And for isolating kernels or any identifiers and all that, it has the Unix time sharing name system, which is called as the UTS namespace. So these are the few namespaces which gets created as soon as you install Docker software, which is addressed as Docker engine in this particular slide. So we have a Docker engine. It's also addressed as Docker daemon. Docker engine or Docker daemon, when it is executed in a machine, it would create that isolated environment and provide containers to have their process isolation, network isolation, volume isolation, and all that stuff. What other technologies does it use? We have an isolated environment, but how much resources that container can use on a specific server, we have to define that as well, right? So control group is the one which limits an application to a specific set of resources. So you can define the needed resources by the container, and you can limit the resources which the container can utilize. So Docker engine would share the available hardware across the set of containers which are running on that same piece of hardware. We can enforce limits and constraints. I can define my container would not go and use beyond so and so limit. You can define those constraints. And it also uses a different technology, the underlying technology, which is coming from the kernel level itself, which is called as union file system. So whatever images of containers that would be saved on the machine, they would be saved in terms of in parts of layers, so that we can make it lightweight and we can make the usage as faster usage as well. So these things together form to create something called as container format. So you have the namespace, you have the control groups, you have the union file system. They together wrap up and they are called as container format. So this defines how the container is, how it would be maintained, how much resources it would use, how will the layers of the images be maintained. So this is the underlying technology of the kernel level, which is being utilized by Docker, so that it can give us quicker and easy wrapper functions using which we can run containers, package them, and build and ship them. The default container format which is there, it has some library functions so that it can talk in Linux terms to the kernel for the namespace allocation, for the control group creation, for the file system running, right? So that is called as library of containers, which is libcontainers. So Docker company, when they developed the Docker software, they wrote this library functions, which is called as libcontainer. And that gives us the ability to write just simple function calls like Docker run type of CLI command. And internally, Docker daemon takes the responsibility of working with the kernel and getting the things done, the isolation done, the limitations done, the storage done in a beautiful way. What are the different use cases where we can use Docker? Wherever we want faster and consistent delivery of our applications, we can use it. Where we want a responsive deployment, we want to scale immediately because it would scale in milliseconds, we can use them. When we want to run much more of workload on the same piece of hardware, we can use containers for that as well. So whenever we are saying containers in Docker, they both sound to be like a synonym, right? Docker is a type of container and it's one of the famous containers, I would say. So let's see, how does the architecture look like? When you're installing the Docker software, it is actually getting a Docker package download, and then you go ahead and start the Docker daemon. When you start the Docker daemon, it has a layer of something called as REST API, which understands the commands which we enter from the client. So client is also there and the server is also there if you see in this. So client makes the command call and REST API takes that and provides that to the Docker daemon. So this Docker daemon helps us manage containers, it helps us manage images, it helps us manage network, it helps us manage the volumes as well. So these 4 blocks in this picture, the container, the image, the data volume, and the network, are called as Docker objects. Any of the resources which Docker can create, that would be at rest as Docker object or Docker resource, and daemon takes the responsibility of managing these Docker resource. Going ahead in few slides, we would be dissecting the Docker daemon into further more blocks, but for our understanding now, we should understand as soon as you are deploying or you're downloading the software and starting the service, Docker application runs like a daemon. When we say daemon, it is like an ever-running application, and there can be only one daemon process of a type in a machine. So in one server, I can have one Docker daemon up and running, which will help us manage all the objects which the Docker can create and work with. What benefits are we getting? We are quickly running, quickly shipping, and quickly building these containers, and we are deploying them. It is deployable, it is scalable. We are having faster delivery of those applications because they are very small in size and they are quicker to make, build, and deploy. And when we have the higher density workload to be run on the same piece of hardware, containers are the best solution. And it helps us, aids us with quick deployment for easy management as well. So we can get a management layer on top of it and manage these containers much more easily.
How to install and configure a Docker. So let's first begin with what all things we are going to cover in this video. So we'll first begin with what are the installation options that Docker provides. So things like editions, which is community and enterprise edition. Then we'll look at installation location, where or what all places we can install this Docker container, and then supported operating system, and then different methods to install. Then we are going to look at what all options you have to practice your Docker installation or Docker containers, covering a desktop, server install, and a sandbox, which is a play environment. Then we look at two different options that you get for a Docker. One is stable version versus edge version, and what each of these means. Then we'll look at those 3 different installation types, which is Docker for desktop, and what all options you have within desktop you get. And then when you install, how Docker can run for Windows, Docker can run in both Linux mode as well as the Windows mode. What that means is we'll talk about that as well. Then we'll look at how to install and configure on Mac, and then finally on Linux machine. We'll also have a quiz in order for you to see how much you've learned in this video. And then I'll tell you the hands-on lab that you must perform. There'll be a separate video for hands-on lab. We are going to do it on a Linux machine or Ubuntu machine that's running on the cloud. So how do you create an account on Azure cloud, and then how do you then go and install the Docker on top of that? So let's first begin with the installation options you have. So if you look at the Docker editions, there are 2 different types of editions that are available. One is community edition, and this is the free version of the Docker that you get. And then second is enterprise edition, and enterprise edition is a paid version where Docker will make sure and validate that everything works. And most of the time, community edition is absolutely free. A lot of enterprises uses this community edition. The only thing is difference is that if there's any problem on that Docker, then you have to reach out to community. Docker Inc. as a company will not help on that part. The Docker Inc. or the enterprise edition that you see, which is a paid version, is available from Docker Inc. Now, in terms of installation location, you can either install this Docker on-premise, like you have existing data center at a customer premises, and in that data center you are running some servers, you can run it there. Or you can install Docker on cloud, where you have a Linux or Windows machines, and on top of that you are installing that Docker, which is Azure cloud or Oracle cloud, AWS or Google cloud. Now, there's another version of container, which is a native container service that each of these cloud vendors provide. So I'm not talking about this installation there, but that's another option where you have Azure Container Instance or ACI, something similar to that you have in from AWS. You have the Elastic Container Service or ECS. and so on. So that's something different. That's platform as a service. This is the same Docker software that you install on premise. You're doing the same thing but on cloud. And third one is on your laptop or desktop. Now, apart from that, the supported operating system, Docker, you can install either on Linux, Windows, or Mac machine. And then finally, you can install using the method you can use on installation. It can be a manual method, it could be a scripted method, or it could be a wizard-based method, which give you options to install. So this is a screenshot on from DockerHub, and this is where you get this Docker software. So if you go to hub.docker.com and if you search under the container or Docker Hub, you will see two editions, which is EE, which is Enterprise Edition, that's paid one, and then Community Edition, which is CE, which is free one. And then you can filter based on your operating system, whether it's Mac or you want to install on AWS or Fedora or Ubuntu or Windows, you will get all those things from here. You can also search it based on operating system or architecture, whether it's a x86 64-bit operating system or IBM or ARM, these are various architecture of operating system. Then if you want to do the practice, and this is probably we'll be doing practice, you have a couple of options. You can install something called as Docker Desktop, and Docker Desktop is good for your development environment or the play environment. And within that, you have an option. You can either install on Windows laptop or you can do it on a Mac desktop, or you can have in a typical enterprise deployment, you'll be putting it on a server install, which is a Linux or Windows server. You can have a Linux server, or you can download and install a Windows server, and on top of that you can install Docker. Now typically this is how you do on your production deployments, but you can use the same environment for the practice as well if you want. There's a third thing, which is Sandbox. This is a project run by two gentlemen, which is listed here. If you go to labs.play-with-docker.com, here you get 3 or I think roughly around 4 hours at, I think it's a per day basis, or at any given point in time, whether for the next 4 hours you will have an environment on which you can play or you can configure the Docker. So kind of a Linux machine that we build, something similar to that, so you can install the Docker on that. If you want to install on a desktop, you can install it on a desktop, which says you can download Docker Desktop for Windows. If you're installing on Windows, it only works with Windows 10 Professional, or there's one more operating system, I think, Enterprise Desktop version. It only works for Professional and Enterprise. It doesn't work on Home Edition version of Windows. If you want to install it on Home Edition, you might have to install something additional thing, which is called as Docker Toolbox. And then if your operating system is a Home Edition or a previous version, then you first install Docker Toolkit, and then you can install. This is for Docker Desktop. So that's a Docker for practice. Now within Docker, you get two versions of a Docker. You have a stable version and the edge version. And as name suggests, in a production deployment, you will be using stable version. Now, what Docker does is they release on a typically monthly basis. They release new functionality, and that functionality comes, or the kind of a beta features, they come into Edge release, our Edge channel. And if you want to practice or if you want to see some of the latest features, then you can use Edge channel. Now, when you download the Docker on your Windows laptop or for practice, you can switch between stable version and the Edge version. There's an option you get for you to configure that. So that's stable versus edge. Typically, you'll be doing stable version. Now, if we now let's look at Docker on desktop, which is for Windows version. So there is a Docker desktop for Windows, and there's a Docker desktop for a Mac. So Docker desktop for Windows, it runs on a 64-bit Windows machine and typically used for development purpose. Now, it only currently supports Windows 10 Professional or Windows 10 Enterprise version. If you have a Windows 10 Home Edition or the previous version, then you have to install something called as Docker Toolbox, and that's available again from Docker Hub. Now, Docker Desktop for Windows also comes with Docker Compose. Now, Docker Compose is a tool that helps you in running multi-container Docker applications. So you have a Docker application that runs on multiple containers or multi-containers. Then in that case, you will need Docker Compose as a tool to build it, and that's where it comes. The desktop version comes with that tool. Desktop version also comes with Kubernetes. Now we have not, probably you might have not have looked the Kubernetes yet. Kubernetes is an orchestration and management layer. In the later part, we are going to look and go deep into the Kubernetes module, and we cover Kubernetes in depth in about that. But for the time being, Kubernetes, assume it's a management layer that manages multiple containers or multiple containers running on multiple hosts and collection of containers together called pods. So you don't need to worry about that. Assume just a management layer which is managing your different containers running on different machines. So that also you get Kubernetes, but in a standalone mode, which means only the single node with Kubernetes server and client. So you want to practice or you want to see a basic version of Kubernetes, you can enable that. How you can enable? When you download once you've installed the Kubernetes, once you've installed the Docker, you just need to go to the preferences or settings, and under that go to Kubernetes, and which is written here under enable Kubernetes, you select it here. So that's for Kubernetes. Now, Docker Desktop, it can run in two modes. It can run native Windows container, which means you can underlying architecture is for a Docker Desktop is on Windows, and you can run native Windows container, or you can run it on a Linux containers or on a Linux-based architecture. And what it means by is this is the screenshot I've taken from left-hand side is where by default, this is the default one where Linux, what happens is on a desktop, when you download a Docker for Windows, underlying behind the scene, it runs as a Hyper-V or a virtualization layer, and under that it runs a small Linux virtual machine. So if you see here, under the server here, the operating system architecture is Linux AMD or Linux 1. You can toggle, you can switch. There will be preferences again on when you install in your start menu. When you configure Docker, or you can change it, and you can change it to the Windows. You will get an option to change it to Windows. You will have to restart your Docker desktop. And now if you see the server side operating system architecture is Windows AMD. So you can run Windows or Linux in whatever flavor you want natively for those containers. Now that's for Windows desktop. You can also install on Mac. And again, you need to download a specific Docker desktop for Mac. And when you download these, as of probably when you download, it will give you what all operating system or Mac versions it's supported. So if it's Mac OS version 10.13 or new version. If you're in an older version, then what you need to do is again same. You need to download a Docker toolbox, and you run your Docker toolbox, and then you can run or configure or install Mac. Now, Mac only supports the Linux version. It doesn't support the Windows version. Mac behind the scene underlying, again, it's running a small virtual machine of Linux on which the Docker is being running. But when you run Mac, you can only run the Linux based flavor for that. Installation is simple. For Windows also, you download the Windows one and then double click and you can install. It's pretty straightforward, very simple install. So you go to DockerHub, download for Windows and install, double click and install. So on Mac also it's simple. You download the app from here on DockerHub. You go to DockerHub and search for Docker Desktop for Mac, download for Mac, and just drag and drop application onto under applications folder. If you're using Mac, this is how you typically install all the other software. So you do install Mac for that. Then for final one is Linux. We have a step-by-step guide or hands-on and a video for that. So I'm not going to go too deep, but very quickly, just for completeness, what you need to do is, let's assume you have Ubuntu. We are installing Ubuntu. You can do it on Red Hat and other versions as well. So what Docker does is, and maybe in future they might release a free version, but if you're doing Red Hat is a paid Linux version. So they release a paid version of that, which is a enterprise edition. They might be released community by the time I'm recording or by the time you're listening that. So you can skip that part. But this is for Ubuntu. What you do is you first update the normal packages on Ubuntu. So this is what we are doing. We're updating the package. And then optionally, if you have already installed Docker in past, you can remove it. But chances are, if it's a new Ubuntu machine, you won't need to uninstall because there's no Docker installed. So what you do, you can sudo and then install the Docker using apt, which is a repository update, or this is how you install all the packages. So you say install and docker.io, and then you enable the Docker service and start the service. And then one thing you need to do is whosoever is going to run. By default, when you create or install the Docker, it will create a group called Docker, which you see here at the bottom. You see a group called Docker. So this particular group here will be created automatically for you. So whatever user that is going to run the Docker container, that user must be added into this group here. So the user in my case is the Docker machine user. This user should be added into this group, and this is the command for this, which is saying user modify and append the group Docker to this user called Docker machine user. And once this is done, all I need to do is that's pretty much Docker installed. And then you see Docker space version. And once you run it, it will tell you the client is Linux AMD and my server is running Linux AMD. It's Docker version 19.03.6 version of Docker. So that's pretty much on installing on Linux. So just to do a quick recap, you do Docker desktop on Windows, double click, simple, straightforward. Same thing is for Mac, straightforward, download it and drag and drop into application. For Linux, Ubuntu, it's again very simple, just RPM package and job done. Now we have not yet created containers. Probably I'll tell about what is image, what is containers in one of the future videos or episodes or videos on this on the module. So that's pretty much, we have just installed the Docker container. Now, just one quick quiz to understand whether you remembered what I said earlier. So first one was, what is the best edition of Docker? Sorry, not editor. What is the best edition of Docker for Windows 10 Professional or Enterprise? Remember I said that Docker Desktop for Windows Professional or 10 or Enterprise Edition. So Docker Toolbox, we know that Toolbox is required if you have a home edition or you have previous version of Windows or desktop. In that case, you need Toolbox, so it's not required. Now, Docker's dumb, you shouldn't install it anywhere. That's not right. Docker machine is not required. So it's only the Docker desktop for Windows. So this is the correct answer. Now we'll put this in the quiz as well if you want to test it. But think before next time you pause. Here's the next question. Don't pause this video here for a minute and see if you can answer. Now, why might you use Docker Toolbox? And I think I hinted in the previous quiz here, the Toolbox is required if your operating system is of version which prior to 10. Now, if you look at Toolbox has a better GUI, no, that's not the reason for this. You're trying to build a machine structure and install it by accident, that's also wrong. You want to use Docker machine, that's not right either. It's actually because we are running a version which is prior to Windows 10. Now, why? Because with Windows 10, what Microsoft have done is they've introduced a small Hyper-V, which is a virtualization or virtual, on which this Docker container or Docker server runs. So that's how it does it. Because in the previous Windows, you don't have that virtualization layer. So that's what Toolkit provides, that virtualization layer actually. So that's basically in a nutshell about it. How to register free for a Azure cloud account so that you can practice your Azure hands-on lab that you might be doing either on certification AZ900 or AZ103, 104, 300 or any other training related to Microsoft Azure. So we'll first begin with how to register for this free trial account from Azure, Microsoft Azure, and then we'll look at how can you access that console or cloud console so that you can practice and do things like creating identity and access management, networking, compute, storage, Active Directory, or SQL Server or SQL Microsoft SQL database or any other activity that you want to perform on this. Now, what you will notice on all the activity guides are editions, which will tell what is the latest or what edition of this guide is. And as you might be seeing right now, things might change in future and we might update the guides as things go forward or as anything changes. It will also have a list of last update, which means first 2 digits are for year and next 2 digits are for month and next 2 digits are on day. So that last update is on February the 9th, 2020. So year, month, and date. Now, all the guides will have an index which will tell what to refer and if you want to go straight to a particular page. So we'll begin with the introduction. Then we'll look at documentation link that you might want to go and read more about these topics, like things like frequently asked questions, what things are free, Oh, that's sorry, that's documentation link. Then we'll look at frequently asked questions, what you will get free, when, how long. Then in chapter 4, we are going to talk about how to register for this free trial account. And then in 5th, we'll access the console and we'll give a very brief overview about the console. And then in next less video, we'll talk a little bit more about these consoles. So let's first begin with the introduction, which is about what this guide is about. And in that, there's a chapter second is about documentation link. So you will also get a step-by-step PDF activity guide. So you can use that guide and go to these URLs. First, beginning with the sign-in URL, which is azure.com, and you can go on azure.com and access for a free trial account. If you want to have some questions, most of the questions are answered in frequently asked questions FAQ on Azure free account. You can get this URL. Now, any of these URLs change, we'll update the guide as well. Now, if you're a student or if you don't have a credit card and you are still studying, then in that case, you may not have a credit card. So you can then register free from your student ID without a credit card. But what you will need is you will only get $100 free compared to when you have a credit card, then you get $200 free. So you can still register without a credit card, but you need your student email address in that case. Then fourth link is for Azure Cloud homepage. How does Azure Cloud homepage look like? So what you're going to get is a 12-month of free services. So first of all, when you register with a credit card, you will get a $200 credit that you can use, and that should be sufficient for 30 days to practice. Now, most of the question we get on our training is that, oh, what to do after 30 days? Then maybe you use a different credit or use a different email address and phone number and create another trial account if you want to practice post 30 days and so on. Now, out of these, within that, once you have done that a month pass, or the Microsoft will not charge unless you upgrade it to the paid account. So make sure you are careful. Don't upgrade to paid account, or if you upgrade to paid account, you remember that you'll be charged for the services. So after 30 days, you can continue using the services, but you'll not be able to create any more. And the machines that are created within that free 12-month free services, only those, and within that limit will be free. So remember that as well. So my suggestion to you would be, if you don't want to pay, then after 30 days, don't upgrade to live session or live paid program. So these are the services which are free for 12 months. Again, best place is to look at the documentation, which is given above. To that shows which service is free for how long. And then some products are always free, and these are very limited. For example, app service, we'll look at what is app service, or functions, and within functions, these many functions per month, or event grid, or Kubernetes services. We'll look at what all these services are, or Active Directory, B2C. All these services are within some limits are free. So, and we'll also look at what these different services are. So that's free. Now, next move on to how to register for this trial account. So first you'll go to the azure.com, and then you go to top right where you see free account, and you'll click on free account, and then you will land on a page like that. And then you need to first register for the Microsoft account. And once you have the Microsoft account registered, then you can go for a free account. So let me first go onto the Azure portal and show it to you. So I'm going to azure.com. So rather than going to Azure for a student, I'll go for azure.com and hit enter. And then if you see here on right hand side, free account, click on a free account. Now you will get a create your Azure account free today. Get started with 12 months of free service. Now screens might change slightly later if you see. So don't worry if the screen changes. And click on start free. Now you should have a email address registered with Microsoft Online. So if I say use another account, and you can create, if you don't have any account with Microsoft here, you can create one. So I'm creating, for example, I've already have an account. I can create it otherwise with K21Technologies@gmail.com. I'm not going to use this account. I already have created this account, but let's assume if I want to create an account, and it say create a password for this account. We are not creating a cloud account yet. We're only creating a account on Microsoft. So I'm based in the United Kingdom, so I'll say January the 1st, and then maybe a year. This is a dummy account which I'm creating, so maybe 1980, and next. And it will send me a verification code, which I can get the verification code in the email address. And again, this is a one-time activity, and right now we are not yet on the actual account. So I'm on that Gmail account, and I got a confirmation saying Microsoft account, verify your email address. So I got a number 6013. So let's continue using this document or this email address itself, 6013, and click on next. Now it's asking me before I proceed, just enter the content or this account here. So 𝐂𝐨𝐬𝐤𝐞 S3N, and click on next. This is basically to make sure that it's not a spam and it's a genuine account or a human being. And now I'm back. I've signed in now, right now, using my account K21Technologies@gmail.com. So now I have a not cloud account. I have a Microsoft account right now, and now I'm trying to create a Azure account. So first country, depending on where you are, wherever your credit card, the card is registered with the country. So you make sure you use that credit card, or the country where the credit card is registered. In my case, I'm based in United Kingdom. I'll use United Kingdom. My first name is Atul, and last name is Kumar. And the email address that I used was K21Technologies@gmail.com. So make sure you use the same email which you've used here. And then phone number, and then company VAT ID. I have a company VAT ID, but then I don't remember it, so I'll leave it optional field. I'll leave it blank. Click next. Now you need to make sure you give a phone number with select a country, correct country code and the phone number. And it says either text me or call me. So I'm saying text me, and I'll get a message on this number which I need to verify. This is to genuinely see that the phone number is correct. So I got the code number, which is 363826. It will be different depending on what time. So I'll click on verify code. And now I'm on a screen which is my cardholder name. So I'll enter my card name, Atul Kumar. Oh. And then I'll put the card number. So what I'm going to do is I'm going to stop the recording for some time. I'll enter the card number and all the country and click on next. So I'm not going to show that details here, but make sure you have either a Visa card, American Express, or MasterCard, one of these three cards. And another thing I've noticed is if you are from India or any other country that doesn't have an international credit card enabled, make sure you enable international credit payments. Because it's going to deduct depending on which country you are, anything roughly around $1 or 2 Indian rupees or INR if you're from India, or depending on which country you are, it might deduct a very small amount, which is equivalent to, as I said, minimal, roughly around $1, which will be returned back to your account. So they want to verify that the card is genuine. And if you decide to upgrade, they should be able to take payment out from that card. So that's why this card is required. So I'm going to stop recording now, but make sure if there's a problem, you reach out to your bank and tell them that you're expecting a payment to be done to someone in possibly it's Singapore, or depending on which country you are, it might be the same country, it could be other countries. So make sure that you have a international payment enabled. So let me pause it and I'll come back once I've entered my credit card details. Okay, so I've entered my card number and its identity verification by card. It's already verified by phone number as well as by the card number. And under agreement, you need to say, I agree to subscription agreement and select this. If you want to get the tips from Microsoft, then select this. And if you don't want any tips or newsletter or any update, then you can uncheck the second button. My suggestion to you would be keep it checked so that you can see any new offers, new things or tips on Microsoft Azure. Click on sign up, and now it's going to validate your account. So I'm getting $150 pounds credit, which is equivalent to roughly around $200 in credit from Microsoft Azure. So it's signing me up, and it'll give me, now it's saying setting up your account. It's basically setting up my account and behind the scenes. Let me see if I get any emails on my Gmail. It's nothing right now. So it's only the first email address, which was verify my phone number, or sorry, my email ID. So it's setting up my account, and I'll pause this recording for a few minutes. Now I get a message saying that you're ready to start with Azure, and you can go to the portal. If you scroll down, you can say join the demo of the C Azure in action, and it'll tell you some tips and tricks as well here. Now, if you want a live demo to or watch on demand, then there's some more content related to the training material which Oracle provides. So I can say watch on demand and register for the demos. I'll register for the demo here, and I'll change the address K21, or I'll leave it to my personal account, official email address, and then I accept and click submit. Again, you don't need to do it. This is mainly for a training on demand. The more content, and again, in the training program, we are going to cover most of the things which are important things for you to learn. So you can skip that if you want. Now I've created my account, and I can now go to the portal by clicking on this button here, portal, which is portal.azure.com. And because I've already logged in, it may not even ask me to log in again, but let me log out from here, and this is the console here, which you'll be able to access it. I'm going to log in again and tell you a little bit about navigation. So that you have completed this registration part. If you want, you can look at the tour, and you can take a tour which says that this is where left hand side, this is where you're going to create all the resources. So it's guiding me now. It'll give you a glimpse of what to expect where. So this is where you go and create all the resources like your app services, your databases, your storage, networking, all the building blocks for Azure, Microsoft Azure. Then you click on next. This is where home page is, and this is where to see all the services, common task, recently used resources, or online training, everything under this one single home page. This is your dashboard, and you can customize this dashboard to display what exactly you want to see on the dashboard. So it's quite handy. There's a mobile app as well. If you notice, we'll download this app as well later. And then this is where you will have all the services which are available from Microsoft Azure. We'll see that as well in a minute. Now, this is where all your favorites are. You can set your favorites, and basically for quickly going to that particular services. So all your Azure resources are under here, under favorites. Now, this is where you can quickly search for any resource on here, top and right side here, any resources you want to access. Then this is where your directory and subscription. So you can switch between the directories or use a global subscription filter to filter the resources in the portal. I'm going to discuss about this a little bit later. You may not need it right now. Then this is where you will get all the notifications, which will tell, like, let's suppose we have just created an account. If any services have gone down, or if you're coming closer to your using all the amount that you have, all those things will be mentioned here. Then this is where you can go and take help from Microsoft Azure, or reach out to their support team to create a support ticket. And this is where your account details are. So I've used K21Technologies@gmail.com. I don't monitor this email, so please don't send any email to that. Your email will be missed or not picked up. So then you can click on finish here, and this is what we have created, a trial account on Azure. I'm going to cover remaining things in subsequent videos. So big congratulations for understanding this. Now task on you is go and create a trial account. If you don't already have, make sure you create first a email address, register your email address with Microsoft website, and using that email address, then you can create a Azure trial account. So just to look at a recap, we have already created these, entered our passwords. We have entered our details on this. We have entered our phone number. We have also entered the credit card. Now, credit card are important for you is if you don't have a credit card, you can create an account using a your college email ID or school email ID if you're a student, then you can still create an account, but without a credit card. But in that case, you will only get $100 or I think $150 credit for this. Now, this account or documentation is based on India when we were registering from India, and the video I've showed you registering from UK. You might screens might be slightly different and the amount might be slightly different depending on if you're doing it from US, Singapore, Australia, or depending whatever country you are from. And then once you're verified, you can then be able to, oh, let me see if I got an email saying welcome to Azure free account and whether we got a confirmation or not. So if you see my email address, I also got an email saying welcome your Azure free account, and this is where you will see Azure Live Portal and understand the cloud fundamentals as well. So we'll cover these fundamentals in our training program, so you don't need to worry about it. We'll try to make short and concise. There's already a lot of information available on the portal or on different sites. The challenge right now is how to understand, see what is relevant, and only focus on things that you need at that point. We want to avoid information overload to you and focus on what is required in order to achieve a particular objective. So make sure you keep these links handy, and if you want to learn more, there's a lot of material already available, but we'll cover in the training program as well. So you've already taken a tour. You know how to log in now and walk through on the different services. And that's how we have completed, or big congratulations that you've completed the activity guide 1 on creating a trial account. We'll use this account in future now to create all the services. So now, action on you, go and create a trial account and make sure you can log into the Azure. How to create a Ubuntu machine and connect to that machine on Microsoft Azure Cloud. I'm creating this Ubuntu machine in order to install and configure Docker on top of that in our Docker and Kubernetes training. So if you're watching this somewhere else, now you can use this same Linux machine for some other purpose as well, or this Ubuntu machine for some other purpose as well. But my primary purpose is after this, I'm going to install Docker in the separate video, Docker on this machine. So let's first look at how this guide is organized. This guide is available on the membership portal, so you can download this guide. At the time of recording this, the edition is 3rd. I'm recording it on 27th of June. If anything changes in future, we'll update this guide. So how do you create a Ubuntu machine of version 18.04? You might be, by the time you're watching this, it might be in next version 19 or whatever. That's fine. You can still use the same guide. Now, first this is where you see index, which will cover what this guide is about and the documentation that we have used in order to prepare this guide. Also, we'll talk about prerequisite if there's any prerequisite before this. So in this particular case, the prerequisite is that you've already created a Azure account or as account on Azure Cloud, which probably we recommend you to create a trial account for 30 days. And then once these 30 days are over, you can create another trial account. Or you can also use your existing account if you already have an existing account. Then we'll talk about how to create a virtual machine of type Ubuntu, and then how to create or connect to this machine. There are 2 ways, using password or using SSH keys. And now if you're a beginner, I would suggest to use password, because SSH keys, if you're not coming from a Linux background, then you may not understand the SSH, so you can skip this connecting using SSH key. Or when you're creating this virtual machine or Ubuntu machine, that time you will select whether you want to configure a username, password, or SSH key. So we'll look into that. And then finally, once you're done, make sure, or once before you log off, make sure you stop the virtual machine. Otherwise, you'll be charged. Or when you say charge trial account, you would not get charged until you upgrade it to the paid account. But if you leave it running, you'll be charged, or you'll be done out of the money. When I say charged, your amount will be deducted, or the free credit you get is $200. You'll reduce that $200, or you will use that $200 quickly if you're not shut down your compute after use. So make sure you shut down. And once you're done with this lab exercise, all the lab exercises, you can terminate that, which means completely, it will remove completely this machine from the server. Now, if you need any help, if anything is not clear after going through this, then you can reach out to support@K21Academy.com for help, or you can ask in our WhatsApp group. So there are different type of accounts. You can read it, but I'm not going to go into this much detail. We are creating a virtual machine of Ubuntu, but feel free to read this documentation here. Now, this is the documentation we used in order to create Ubuntu machine. Now, this is as I said, there's a prerequisite activity guide. That activity guide, assuming you've already followed. If you already have a trial account, or if you already have an Azure account, or if you know how to create one, then you can skip guide. Otherwise, if you don't know how to create a trial account, you follow this previous video in order to create a Azure trial account. So I'm assuming you already have a trial account. So then what we're going to go is we are going to go to Azure portal and then straight say create a virtual machine. So you select from the search bar, you select search for virtual machine. So you go and say create a virtual machine, and then by clicking add, you will come on a create virtual machine screen. You provide some parameters. I'll explain you in a minute when we go to that screen. So you select subscription, you select a resource group. If you're creating first time, you basically are creating, or you will create a new resource group. There are other details. I'll explain that when we are on the portal itself. And this is where you provide all the details and you click on create. Once you've created this, as I was talking about, you can either select SSH public key, or you can use, this is private public key. So you can either use SSH keys to connect, but that means you should already have SSH keys. Again, if you want to use in our Azure administration training or Azure solution architect training, which is AZ300, or Azure administration AZ104, we cover these in detail. But if you're a beginner, maybe I would suggest leave it password and select username password. Or if you want SSH keys, make sure you create SSH keys, and instead of username password, you select SSH keys. Now, you also select inbound port, which means there's a firewall by default configured. You are allowing port number 22, which is SSH port. And then you click on create. Once the machine is created, you go to this screen again on the machine and click on connect. Now connect, you can use SSH key because it's a Linux machine. We are going to connect using SSH key or SSH. And this is where you select, when you say connect on SSH, you will get a PuTTY, and it will be running. PuTTY is a terminal window through which you can connect to a Linux machine. And then the user that you've created at the time of account creation, that's what we're going to use. Once you log into the machine, then in the next video, we're going to install Docker and Kubernetes on this. So let me straight go into the portal or Azure portal and show you, and we'll come to the screen and I'll parallelly look at this documentation. I'll explain what each of these mean. So if you notice here, I'm on Azure portal. I've already logged in. And this is my landing page. So from here, I'll go on to top search and you type virtual machine and you click on virtual machines here. And right now, if you notice, I've already created a machine. My colleague Piyush created already a machine with the name Docker machine. So I'll click on add and say I want to create a new machine. Just wanted to show you how does it look like. So click on create a virtual machine. And the first thing you'll be saying is subscription. Now there are different types of subscriptions. This is a student account, so that's why you see Azure for student. Otherwise, you will probably see your subscription that you've created at the time of, you got it at the time of account creation. Now here, by default, when you go, there'll be no resource group, but we've already created some resource group. Resource group is nothing but collection of resources. In this case, virtual machine is a resource, network is a resource, storage is a resource, and so on. So we place all these resources in a resource group. Now I've already created a resource group called Docker machine group, or let me create a new, and whatever of your choice. Maybe I'll say Docker practice, or let's see in the documentation what I've used. So in the documentation, we have used Docker machine. So let me go and say Docker machine is already there. So probably I'll use or leave it Docker machine. I think it's not there. Name is slightly different. So click OK. So it's creating that, it'll create a resource group. Now this is my machine name of the machine. You can pick off anything of your choice. So again, say Docker machine. You can pick whatever name you prefer. And then you select a region in which it's going to create this machine. So I'll select US East. I've heard is the US East is the cheapest. So I'll probably say US Central, not East. One second. Yeah, US East, US. These within East US there are two data centers. So I'll select US East, and then this is for high availability. Again, I've done a previous videos on our YouTube channel. If you want to know more about what is availability zone and availability set, the URL is youtube.com/K21Academy. Just search around it, or there should be, I think, K21Academy.com/AZ104, 11, 12, 13, and so on. So we are not configuring any high availability. Now, image is Ubuntu. This is where I want Ubuntu server. So it's already picked up by default Ubuntu. The image version is 18.04 for me at the time of writing this or recording this. If it's a higher version, that should also work. Now, um, then as your spot instances is something basically they means Azure might take these instances if they need it back, and these are slightly cheaper, but Azure or Microsoft might take this away from you if required, if they need additional capacity. So we don't want spot instances. We'll select size of your choice. Basically, if I select this, which is 2 vCPUs and 8 gig memory, and let me see what shape we have selected on the portal. It depends now how many Docker containers you want to run on this Ubuntu machine. Depending on that, you will select the memory and CPUs. So in the documentation, I've selected a D2V3, which is 8 GB memory and 2 vCPU. So I think we are good with this. Leave it default. And this is where my authentication to the machine is using password and not SSH keys. So the name, I'm going to keep it as username to connect is as your user, same as machine name. So we'll leave it to default. It picked up as your user. You can pick any name of your choice. Because my machine name is, one second, I think I'll change it. I'll say it, the machine name is Docker machine. So for easy to remember, I'll say Docker machine and I'll say user. So just this is a naming convention, and a password of your choice. I'll save something. And let's see this password. And then this is important. You say that public inbound port. If you select none, which means it will block everything. We want to allow port, and which port we need port number 22. Because it's a Linux machine, 22 is selected. You don't need, you can do 80 if you're running a service on, and maybe in future we might run some service on 80 and 443 on this host. So let's allow right now all three ports, 22, 443, and 80. Right now I'll be connecting to this machine on port 22. But if I install a web server on the Docker container, then I'll might map it to that IP. So that's why let's keep it port number 80 and 443 also open. Now this is where it's showing me a warning that this is only recommended for testing purpose. Don't allow 22 from public. We are okay with that because we are using it for testing. Now this is where it's prompting me to next is disk. I need some disks. So by default, it will leave it default once, and we'll keep default disk. I'm not going to go into these disk and networking. As I said, we cover these in detail in our Azure administration as well as Azure solution architect training. Next is we click on networking, and this is where it's creating a virtual network. It automatically is creating some default values, and it's picked up default subnet and public IP as well. So it has picked up all the basic things which require network interface cards. So I'm going to leave all these default. It's basically creating all these things for me. And then next is management. Again, I'll leave all these default. So I can leave all these default. I'll simply say create and review, or review and create. So it'll give me all the options that I've used. So if you see, it's going to cost me per hour roughly around 6 rupees in Indian rupees, which is I think 6 cents or something, quite cheap. And it's subscription credits. I have some money left on this, and it's saying this is my subscription. This is my resource group, which it's part of. The name is Docker machine. Username should be, if I go down, Docker machine user. This is my disk type, premium solid state disk. Networking, it is creating a VNet. This is my default IP subnet, and it's assigning a public IP, and so on. And simply say create, and this will go and create this machine now on cloud. If you see here on top right notification, it's saying submitting deployment in progress, and it'll take few minutes to create this machine. It's quite prompt actually. So now I'm getting a message saying your deployment is underway. It's basically picking up this resource, and the request has been accepted. And wait for a few minutes, you will come and you will see under compute, you will be able to see, or under virtual machines, you will be able to see the machine that we've created. So if I scroll down here, and my virtual machine on left hand side, this is my menu where I have all my virtual machines, and it should come under here. So right now this was the machine which was created by my colleague, and you can filter it based on the resource group as well. So for now I've selected all the resources group, and we created a resource group. I think, oh, it's yet to create this resource group, so it's creating those resource groups. Now if you see, I got my machine, Docker machine. This is the one which we created. It's saying status is creating. Give us few minutes, and then if let it create fully, and then we'll connect it. So if you click on this here, on top you'll come here and say connect to this machine, and once it's fully covered, I can start and stop. If you see deployment successful, the message I got immediately is deployment successful, and it says I can pin it to dashboard, I can go to the resource, and right now I'll not do any of that. And I got my machine here. This is how I stop it. I can delete it, which means it will terminate. I can restart this or stop it. Once I stop, these buttons will be enabled as well. So I want to connect to this machine now. So I'll click on connect. And what are the different ways to connect? It's not a RDP, it's not a Windows machine, so I'll not do RDP. I want to do SSH because it's a Linux machine. So I'll click on SSH, and now I can directly find a public IP and connect it, but I have an option here, so I can simply connect here from SSH. And this is if you are connecting via username password, or I can use PuTTY. Open client, connect via SSH client, open the client on your choice, PuTTY or other client, and then we provide these parameters. Now this is my public IP which I got. So this is how I'm going to connect. So I'll download the PuTTY, should be already on my plate, otherwise on my machine, otherwise I'll download it here. And it's giving me a much option to connect. So let me see. I think I've already downloaded PuTTY. If you Google it and then say download PuTTY, you should be able to get it. So this is PuTTY, which is available on Google, putty.exe. I'm connecting from Windows. So this is my machine name, IP, and I'll save it as Docker VM, anything you want, Docker VM and Azure. And I'll save it. And if I had to use SSH key, I would have gone here, and under authentication, I would have selected my private key. So when you connect using SSH key, you first create a public private key using a tool called PuTTYgen. If you're interested, we will, I think let's park it. I don't want to go or complicate things here right now. We'll keep it simple. So you create SSH private public key, and then public key you select at the time of provisioning a machine, and private key you give it here at the time of connection. I'm not using SSH key. I probably are simply using normal username password. So I'll say open, and I should say it's basically accepting the fingerprints. The server is, so I'll say yes, I accept this, trust it. And now this is where I need to now remember the username. And for that, if you see, my machine name was Docker machine user. So machine name and then just user at the back. So Docker machine and user, and hit enter, and the password that you set at the time of creation. And now I'm on the machine here now. So if you see Ubuntu with absolutely no one, this is my host name, and in future I'll be installing Docker and my container on top of this, which is Docker. If you want settings, you can change it. So if I go to my new session, and I prefer a white background and a black text and a little bit bigger font. So I'll go down here. I'll say that my think Docker machine Azure load, and this is where I'll say property appearance. So I'll say font settings. And this is where I'll say fonts are a little bit bigger, 16 size. Okay. And then my colors, I'm going to select a system colors. So I think probably this is the colors here, use system colors, and I'll probably go back to session and say save. Let's see if what I get. Yeah, this is what I wanted. So now I got it, this. And next time I'll connect, I'll have this font and the color white background. So this is all in a nutshell on creating a virtual machine of Ubuntu if you are working on Mac as a client. So let's suppose instead of Windows as a laptop, you're using Mac as a laptop. In that case, how you can configure or access what I did earlier. So this is a machine where I'm connected remotely. I'm recording it from a Windows machine, but what you see on the screen is actually a Mac machine. And I've opened a new browser here. So this is behind the scene, it's a Mac. And I'm going here on that. First thing is you need to log into the Azure. So browser is same. There's no difference. You can go to portal.azure.com. I've already logged into this machine, but I can show you again. And this is how you're going to go and create your Linux machines on the Azure portal. So portal is no different. You access it via the browser. And I've also configured, this is the same machine which I created from this is the same portal which I accessed from the Windows as well. I'll go to the Docker machine and identify the IP address of the Linux machine. So I've created all those things. You can continue following the document I did earlier on how to configure a Linux machine of type Ubuntu, and then make sure your machine is up and running. And you got your IP address from here, or this is the public IP that you'll be using to connect to this. Now go to the, in the Mac, you have something called as terminal. So you start this terminal here, just type for terminal, and this is basically a Linux shell that you get from Windows or from something similar to PuTTY. And now I'm going to do is I'm going to increase the font size of this. So let me first exit. I've already logged on this machine, so I'll exit from this machine and or the Windows machine. And this is the Mac machine. Oh, sorry, this is the Mac machine, the control command prompt. So let me make it slightly bigger. So in fact, this is my wife's laptop. So I picked it from here. So what I need to do is I'm going to type SSH and the username of the Windows machine. So I'll type as Docker. The username is my Docker machine and user at the IP address for my public IP of this Linux machine, which is, if you see on the right hand side, which is 40. If you see here, which is written here, public IP 40.87.27.130. So I'm going to type IP address as 40.87.27.130. If I would have used a keys like SSH key, then I probably might use the location of private key here, but I don't want to confuse you, so ignore that. Assume you already have used username password to log into this machine. So hit enter. And now if you connect first time, it's going to prompt you and say, do you accept keys, SSH keys? You say yes. So it's prompting me for password. So let me enter the password that I created during the machine creation. And now I'm on machine here, host name, and I am back onto the similar to the machine. And rest now, defining the, creating any containers, all those things, I'm going to follow the same process here. So if I say Docker, and I think I use command called version. And now I'm on a server now running exactly same as I do it from Windows. So the only difference in between Mac and Windows are that in Windows, I'm going to use PuTTY to connect to the server, whereas in Mac, I'm going to use the terminal. We call terminal. So you go from here and search from here terminal, and this is what you start. So rest all is same, browser is same in both the ways. Any other difference if I come across, I'll let you know as well.
We would discuss about installing Docker software on Ubuntu-based machine. Docker can be installed on any sort of operating system. It can be a Windows operating system, it can be a Linux, or it can be a Mac OS operating system. We understood that any containerization platform needs operating system on top of the hardware, and then only it can run, because all the containers share the operating system kernel, which is the host operating system's kernel. And that is how it creates container and works with it. So when we are installing Docker, If we are taking Windows Server, Windows Professional or Windows Home Edition, we can install Docker for Windows software on that. We can take Docker for Linux for any of the Linux family. Could it be RHEL, the CentOS, the Debian and all? They have a single flavor called as Docker for Linux. Same way, if I have a Mac OS machine, I can choose Docker for Mac OS. But normally in production, we are using Docker for Linux. We would be going with that flavor. Even for the production environment, we can go ahead with Docker for Windows Server too. But we are more keen towards learning Linux environment application. So we would be installing Docker for Linux in our environment. So I'll take you to the portal.azure.com. That is my Azure portal. And we would be creating a virtual machine in Azure environment, a Ubuntu based virtual machine in Azure environment. So here it is logging into my Azure account, and you can type virtual in the search bar over here, virtual machine. And if you click on that, it would give you the list of the virtual machines if something is running, and it gives you a provision to add a virtual machine. That means it would help us create a virtual machine. And this is the page for creating a virtual machine. You got to feed in these parameters so that you can work with it. Okay, you can create a virtual machine. You can create a resource group. Say, for example, I want to create resource group 2. Resource group is a way in which you can collectively keep all the resources belonging to a logical grouping for a set of resources. So anything I'm using for Docker work, I can have them in a single resource group. You can give a name for your virtual machine, like I can give it as Docker VM, and we can choose the region in which you want to spin up this virtual machine. I have chosen East US 2. This is the image with which you want to spin up your virtual machine. I am choosing Ubuntu 18.04, the server version of Ubuntu. And I'm living with the standard size, 2 virtual CPU, 4 GB RAM. This should be sufficient for us to do our exercises. And I would go with the password-based authentication. Here you can give a username of your choice. I'm giving it as Ubuntu. And I'll supply a password for it. And I will give a password which I can remember and I don't forget. So here, if all the parameters are good, then it shows a green tick mark. We are opening port number 22 as we would be doing SSH to this particular server. So I don't do settings, any other settings apart from this management one, in which I'm making the boot diagnostic off. And with this, the networking, disk, advanced tags, everything remains the same. So I'll just go and hit on review plus create. And if all the parameters which I have supplied for the virtual machine creation make sense, is correct, then this validation pass state should be shown. Once the validation has passed, I'll go and hit on create. This would create a virtual machine in Azure background in the Azure cloud. So this would take a while, 1 or 2 minutes. Let's wait for the virtual machine to come up. And once we have the IP address, we would go ahead and connect to it. So the deployment is completed. You can see your deployment is complete message over here. So I'll go and again type in virtual machine, or it comes in the option, then I'll take that. I'll look why it is not listing over here. Let me select the subscription. This is the virtual machine which I had created. I'll click on that. And in the overview tab, if you see here, the default tab is overview. This is the IP address, the public IP address with which I can connect. So I'll copy that IP address and I'll move to my terminal. So I'm using Mac operating system. That way I can directly connect to the machine by doing SSH. In case you're using Windows-based machine, you can use software like PuTTY to connect to your virtual machine. I have given SSH with Ubuntu, the username which we created for the virtual machine. It's not virtual machine's name, it is username. And this is the IP address. I got to supply the password over here, which we had entered during the virtual machine creation. And boom, I'm inside the virtual machine at this point in time. Let me go ahead and clear the screen. And as soon as the machine is up, normally we go and update our operating system repositories. So as I'm Ubuntu user, I will not be able to update or download any software. So I'll use sudo in front of it. So I'm doing sudo apt-get update -y, and it will update the software packages which are there in this machine. And then we would go ahead and install Docker software. So update is done. Let me go ahead and install Docker software. So apt-get install docker.io is the name of the software. And with this, your Docker package gets downloaded to this machine. So it will connect to the mirrors, it will get that package, and it will download the complete Docker software. Once the Docker software is downloaded, we would start the daemon process, and we would then work with it going further in the next videos. So let's wait for the Docker package to be downloaded completely. So Docker package installation is done. Let me go ahead and start the Docker process, the Docker daemon process. So I would do systemctl and I would say start, and the Docker service name which runs as the daemon process is called as Docker. So I'm saying sudo systemctl start Docker. I would also go ahead and enable it so that anytime my machine restarts, as soon as the machine comes up, Docker is by default up and running. So enable is to make that service up and running so that anytime a machine goes for reboot or we are stopping and starting the machine, Docker would by default come up as soon as the machine is up. Let me check the status of Docker daemon. So we can write status command systemctl status Docker, and you can find that it is up and running over here. It shows active, up and running. You can press Ctrl+C and come back to the terminal again. So Docker software is installed now, and we can go ahead and learn a little bit more basics and then come back to this machine and learn about how to do the hands-on. But before closing this video, what I would do, Ubuntu user doesn't have the capability to run Docker commands by default. So what we would do, we would have Ubuntu server add with the capability of talking to Docker daemon. And for that, you would have to modify that user. So I'm saying user mod, and I would append in group Docker the user which I am working with. So because I am using Ubuntu user, I would be adding Ubuntu user to Docker group, and Docker group got created as soon as Docker software got installed and the daemon started up to run. That time this Docker group is created and Ubuntu gets added to this. In case you're confused which user to add, you can type in id command and you can find what is your username from here, and you would see that Ubuntu user at this point in time doesn't have access. These are the group IDs with the names. It doesn't have access to Docker group. So let me execute this command and give permissions to it to execute commands or the Docker commands. As soon as you have done this, you will have to first exit and again SSH to the same machine with the username. Otherwise, your access doesn't get changed. So for the changes to take into effect, you will have to re-log in the SSH session. So now if you do ID, you should find Docker group to be added for this particular user. So now user ID Ubuntu 1000 user ID has access to Docker group at this point in time. Let's execute Docker -- version command and check if we are able to execute Docker commands. Yes, Docker version is 1903.6 at this point in time.
we are going to talk about how to create and configure Docker. Now, this is going to be a couple of videos all talking about Docker, install, configure, and manage different things. So in this first part, I'll begin with how to install and configure Docker. And then in the next part, we'll talk about image. How do you start? How do you import images? How do you list all those things? Then another video will be about networking and then volume and so on. So let's first begin with, in this video, how to install and configure the Docker. Now, the addition, as I probably might be different on from where you're last picking. If you hit any problem, you can reach out to support@k21academy.com. Now, like we did in previous videos or previous hands-on labs, you will have a introduction about what this guide is about and the documentation which is related to the Docker installation or whatever this guide was prepared, it was used different documents, all those will be listed here. Now, third chapter will be on prerequisite. In order for you to install and configure Docker, you need an underlying operating system. And in our case, we are going to do a Ubuntu. So how do you install Ubuntu, which is covered in one of the previous videos? So all those things will be under prerequisite section here. Then we are going to cover chapter 4 is where we primarily focus, which is install Docker on a Ubuntu machine. And then fifth one will be working with containers. Once this is done, this will be part of this video on remaining, which is images, networking, storage, and external DNS configuration, Docker file. All this will cover in subsequent videos. So moving forward, these are the documentation worth looking at that if you find as and when you find time. But your theory videos and the hands-on lab should be enough for you to begin with. Now, prerequisite point of view, as I said earlier, there are two ways to install and configure or test your Docker or play with the Docker. So first one are the one method is you install Docker on a Linux machine or Ubuntu machine and then run it. That's what we are going to do in this lab. Other option is you go this URL labs.play-with-docker.com, and this is from Docker. It's being like project by these two gentlemen. So you and sponsored by Docker. So you can create an account and play here. In that case, you don't need to install or configure anything. I think you get around 4 hours of worth of environment on a daily basis. So let's go back to the guide. In our guide, for us, we are installing a Linux machine or Ubuntu on Azure, and on that Azure, we are going to do that. So we have already done in previous activity or videos, we first created a trial account and on Azure, and then on the next one, we created a Ubuntu machine in the previous one. So we'll begin with that Ubuntu, and then we'll directly go and start the installation on that. So first part, what we're doing here is we are updating. So Ubuntu itself might need some updates. So Ubuntu might have, so when we installed last in previous video Ubuntu, that Ubuntu might be outdated. Some packages might be, new packages might have come. So we'll update all the packages on that. This is the host machine on which we are going to install Docker. So we'll update all the RPMs on that. That's command 1. Then command 2 is optional. If this is first time you're doing, you skip this. This is only if, let's suppose you already have Docker installed, then you will run it. We'll not run it because we have not installed Docker yet, but this is a way to remove the Docker packages from the server. So step 3, this is where we install Docker. We will say sudo. Sudo is basically we are logging in as a non-privileged user, and sudo means it's going to run this command from a root user. And then we'll type apt space install. We are telling install, and what we are installing, we're installing the package docker.io. So we'll connect to the internet, download it, and then install docker.io. Then we'll say start and enable Docker. So it's a systemctl. Basically, we are telling system commands to start the Docker and then enable it. So next time machine starts, the Docker is enabled. We'll check the status of the Docker to say that the Docker services are running. Then when you install the Docker software or this using the commands mentioned above, it's going to create a group called Docker on the Ubuntu machine. So whatever user you want to start or configure or run your Docker containers, that user should belong to this Docker group. So that's what we are doing in this. We are first identifying the user that we created at the time of Ubuntu creation. In my case, I created a user called Docker machine user, and I'm adding that user in this next command. I'm adding this above user into the Docker group. So I'm saying sudo space user mod I'm saying user modify, and -a-g. -a means append and g means group. Append group Docker to this user ID, which is Docker machine user. So we'll do that. Now, once you add the user, you have to exit from the shell and come back, maybe restart the, or sorry, exit from the putty terminal and log back in. I'm going to show you in a minute. Once you log out and log back in, make sure you do ID one more time and see whether group Docker is, this user is member of group Docker or not. Once you know that this user is a member of the Docker, you just check the Docker version, Docker space, and this is the command. Once you install Docker, you will get Docker as a executable or in the path, and then you can say Docker space and then -- you can use help, you can use version, it will tell you the version of the Docker. Once we have done the Docker, then I'll come back and will work on the Ubuntu. So let me first install the Docker on the first part, and then we'll go and start, and then we'll do the remaining part. So let me first connect to the Azure cloud on which we started or installed our Ubuntu machine. So I'm on a Azure portal here, and this is on home page. I'll click on here from home virtual machines, or you can go here and click on virtual machines. It's the same thing. I'm going to the virtual machine home, and these are the two machines I've already done. This was done by my colleague Piyush, and this is me created this Docker machine. Now I mentioned to you that stop your service once, or the machines once you're done with the task, so that you don't get billed or charged for this machine. So the machine was already stopped. I'll click on that, and first we need to do is start the machine. Or if you would stop, you would have stopped from here. When you stop, you get an option to whether you want to retain the public facing IP, or you want to return back and then start a new IP or get a new IP again. Now, for me, I can live with changing the IP because if you retain the IP, you'll be charged for the IP for whatever long time you need that IP. So I've returned that IP back, so I probably might get a new IP. So my machine is stopped. I'll click on start, and this will now say starting the virtual machine, and it'll take a few minutes, 1 or 2, 3 minutes. And then once the machine starts, we'll be able to go back to connect option here, and then we'll be able to see. So if I click on connect, and I'm going to do SSH, and if I see this is the new IP now. Earlier was a different IP. So I'll click on this, I'll go to putty, and then this is the IP or machine I shared earlier. It was earlier IP52 when I showed it last time. So I'll just simply check that 10.0.3.4 and we'll save it. And I'm saying load it. And because I think it's just starting out, still starting out, so maybe it'll take a few minutes. I'll pause this and then I'll come back here once the machine is up. So if you look here, status is updating, and once it's running, I think it's running, the status will be running, and then I will be able to connect it. So now you see the status is running. So I simply restart the session. Sorry, the public IP was not 10.0, that was the internal IP. The public IP is here, so my mistake. Sorry for that. I'll go back and click on connect here and then say SSH. This is the IP actually, that was the internal IP, so I should have used this. That's why I was unable to connect. So I'll go back and I'll say new session, and this IP, which is 10.0, usually is private IPs. So save it and then I open and say yes. And my username was Docker machine user. So machine name and then word user at the end. So Docker machine user, and hit enter. Password, you should remember the password because you set the password. If you used SSH keys, you use SSH key. Now I'm straight into this machine here, Docker machine. So I've connected to the machine. Now I'm going to first update the repository of this, and let me keep it side by side. So I've copied and I've said update. So I'm updating the operating system or the Docker host operating system. So right now we are not into container, nothing. It's the host on which we are going to install the Docker machine. So it's reading, and I've already downloaded all the packages. So there's no update required. It's saying all updated. Then I've not installed the Docker, so I'll skip this part. And this is where I'm going to install the Docker machine. So I'll say Docker apt install docker.io. And it'll fetch or download the software from it. It's connected to the internet and downloading all the Docker software here. So once the Docker is installed, I'm going to start the Docker. So I'll run the command sudo sysctl start Docker. Now Docker is started, And then I'm going to enable as well this Docker here. So start Docker enable now, and I'm going to check now status of this Docker, whether it's running or not. So if you see here, status is active, it's running, and these are the timestamp, other things, but main important is it's active and running. So just type Q to come out of the control prompt or command prompt. Now next is you need to find out what is the ID of this user. We have already know the ID is usually the ID is here. I think is first one Docker machine user, and my ID is Docker machine user. So what I need to do is then I need to add this user uh, into the group Docker. So I'll say that, or before I go, if you see, oh, I've already added this user in past about this Docker, but I'll probably, this Docker, it should not be for you here. So let me close this and let me go back and run one more time. And when you do ID, you should have something like your Docker number might be different, but the group should be Docker here. Now, where this number group coming? The Docker etc group is the group where you will have the user ID, sorry, group ID. So Docker group has an ID 116, and similarly, the cat etc password has a this is my Docker user, which is or the user that will own the Docker machine, which is Docker machine user, and that has group. So I think this is right now not 116 is not there. Let me come out of this and let me log back in. So I've logged back in here, and ID was always there. Docker. Let's see in etc password whether it has updated the group or not. We should see a user called or group 116 here, but let's see. So I'm going to do a Docker version, and Docker version should work here. So my Docker version is now 19.03.06. This is the build version. And now I can play with container. So I can say what is happening with the container. So let me try running, and maybe if there's a permission issue, if the user doesn't belong to this group, I'll error out. So now I'm running a Docker. If you see here, I'm saying Docker run, and then IT is interactive. It will immediately go and look at the shell here. So if you see here, my user I have is this was a Docker machine host, and now if you see the control prompt have changed, I'm inside the Docker container now as a root user. So if I type now here host name and hit enter, my host name is totally different. If I want to come out of this, I'll say control P and control Q, control P and control Q 2 times. And now I'm back on the machine. And if I do now host name, now my host name is Docker machine. So earlier, if you see prompt here, which was a container, and this was the Docker host. So right now I've already not only installed container or Docker, but I've also started a container. And if I want to see, so the command I think is Docker PS, and it'll tell me all the processes running for Docker. So it's a Docker machine which I started just a minute ago. That is what is running on this machine. I'm going to discuss all this a little bit on the next video, but first, just I've given you a little bit heads up that I've also started a container or a Docker container. So just to do a quick recap on this, what we have done is we started the Ubuntu machine on the Azure, then we went and update the latest update on this Ubuntu machine. Then we installed a Docker software. We enabled and started the Docker, verified the Docker that services are running. This is a Docker container, Docker Daemon we see. And then we identified the user ID that should be starting my Docker machine. In this case, my user ID was Docker machine user. So I've added this user into the Docker group, and then finally I verified the Docker version. And in the next video, we'll look at working with containers. We'll say how to start, stop, connect. This is all in a nutshell about Docker. Now, one thing I want to also remind you again, when you're done with this exercise, make sure you stop your Azure machine or Ubuntu machine, otherwise you'll be charged for that. So how do we stop it? We go back to the Azure console or Azure portal. So I'm on Azure portal. I go back to the Docker machine and I click here and say stop, and say stop this virtual machine. Say yes. And on the first time when I stopped, it gave me an option, do you want to retain this machine? I said no. Yeah, so this is what I was talking about when I select, do you want to reserve the public IP? If you check box, then it will create a or reserve that IP. I don't want, simply say OK, and we'll come after verify that machine has been stopped. So right now it's running, and in a minute it'll come back and come as a stopped, and then you can close, otherwise you'll be charged for this machine. So click here, refresh. So now it's deallocating if you see status, and if you refresh in a minute or two, it'll stop. So this is how you stop the services. So if I do one final time refresh, it says stopped, so it should be stopped now. So now we'll not be charged for the compute, we'll only be charged for storage, slight storage, which is very small. This is my private IP. My public IP has been gone now because I said, oh, take away private IP. I don't want to be charged for public IP. Sorry, private IP is still available. Private IP is gone because I said not to retain it because I get charged otherwise. So this is all in a nutshell about installing the Docker on an Ubuntu machine.
Docker architecture is primarily broken into two parts. One is the client and other is the server part. Client interacts with the Docker daemon, which is the server part, and server does the heavy lifting part of it, running, building, or any creation of containers, images, volume, everything is handled by the Docker daemon. And if we try to visualize, we would have a client from wherein we would execute the Docker commands, and the Docker host, a machine would be addressed as Docker host if it has Docker daemon up and running in it. So this particular server has Docker daemon running in it. So when you run the client commands, the commands from the client machine, it gets in connection with the Docker daemon. Docker daemon picks that and executes the commands with the help of Linux kernels and prepares the container. So a container has a template with which it would spin up the application. It can be an operating system template or it can be an application template itself, right? How we have virtual machine template. That way, for containers, the template is addressed as image. So Docker daemon pulls the image from the remote registry place like hub.docker.com, and then it places that in the local and executes this container. So if you see, this particular Docker daemon is managing the containers plus it is managing the images. In case I have ports and all that exposed for this container outside this Docker host, Docker daemon takes the responsibility of managing the complete network stack plus managing the file system for these containers as well. So Docker daemon is the one which plays the important role. But when they were building this Docker daemon, slowly it became a monolithic type of application doing a lot of work. It had a lot of responsibility: create containers, talk to the kernel, manage containers, manage images, manage file system and all. So that is the reason they broke this daemon into further more smaller modules so that when they are preaching microservices, they themselves develop microservice rather than a monolithic type of application. So Docker daemon uses the client server architecture and does the heavy lifting part of it, and the client is the one using which we interact with the Docker daemon. So if we execute any command, these commands are sent to the Docker daemon via the client. So if we dissect the Docker daemon further, it has a Docker engine. The engine or the daemon is like a synonym. So whatever the Docker daemon was doing, it is being distributed across 4 different components: the Docker engine, containerd, shim, and runc. So these are the 4 components, and this is the final container which is running. So let's understand what each of its components do. Dockerd, or the Docker daemon, is having the responsibility to listen to the API request which comes from the REST API layer from the command line interface. And containerd is the component now which got introduced in Docker 1.11 version. This takes the sole responsibility of managing complete container lifecycle. That means from the time the container is up and running till the time it dies, this is the one who would manage the complete life cycle. And container D, you can call it like an executor. It takes the responsibility to pass on the creation request to runc so that it can talk to the Linux kernel and spin up the container or start the container. Okay, so container D works like an executor for the containers. And when you're executing the containers, you actually call runc, and with the right set of parameters, when you call the runc take those parameters, goes to the Linux kernel and starts the container and exits. We don't want a specific runc for every one container having a dedicated runc, right? Then we would be having a lot of processes running in the system. Rather than that, we have runc creates the container and exits, and then a secondary type of process called as container D shim that would be running, and this helps us to run daemonless type of container. What is daemonless? It doesn't have a parent type of thing. It's like it's running, and in case any exit of that container happens, then this is the process which goes and intimates the container D, because container D is the one which manages the life cycle of the container. Okay, so these are the 4 components using which we are managing the complete Docker daemon. So Docker daemon now is broken into 4 components: Docker D, container D, runc, and container D. We would learn how to work with containers. So we would learn some of the basic commands which would help us to work with containers. First command is the Docker version, which we saw in a few videos back. We saw when we installed Docker, how can you check the version of software, which version of Docker got installed. Docker info is another command which helps us get the complete detail about the Docker daemon which has been up and running, the complete software. And there is a path wherein /var/lib docker, where all the objects created by Docker would be listed. Let it be the images, let it be the containers, the volumes, anything which Docker manages would be listed in this path. And in case you want to do some configuration setting for Docker daemon, then /etc docker is the path for that. So let me take you to my terminal and let me execute the Docker info command and show you what details can we see in this. So Docker info shows us what is the software package number, like 1904. It shows us the storage driver name. It shows the file system which is being used. What is the default logging mechanism? All the containers would be logging as JSON. What is the C group driver which is being used? The volume, what sort of volumes can we mount inside the container? And if you see here, the runtime runc is mentioned over here. And we are not using Docker in the swarm mode, so this shows us inactive. And then you have the kernel version, the operating system version. So this is the complete detail about the virtual machine on which this Docker daemon is up and running, right? And if you see, we would go ahead and connect to the hub.docker.com software of the server, from wherein we will install packages or images for any containers. So this is the one where it lists the registry with which it would be connecting to download the images. So this was the command for Docker info, and you will have to do a sudo and then go to the var/lib docker path. So I'll just quickly show you what does the path contain. Okay, I would have to just do sudo su first, sorry, my bad. And then you can do a cd on var/lib docker. And yes, and if you see here, it lists all the containers, the image, the network, the drivers, the plugins, the runtime, the volumes, everything gets listed over here. And same way, /etc docker is the path for the configuration. At present, that should be empty. By default, no daemon.json file is there. It's just the key.json file, and daemon file settings are not there. So this daemon has come up with default settings, and in case we want to configure any specific parameter for this daemon, we can go ahead and create a daemon.json file and feed in our parameters. We would look into daemon.json when we do the DNS exercise. So I'm going back to the home directory, and let's go further and understand how does the container lifecycle work. Okay, so you can create a container with Docker container create command, and once we execute that command, the container goes to created state. It's created, but it's not up and running. It's existing, but it isn't stopped state. Okay, so we can go ahead and do a Docker container start, and we can start the container. As soon as you start the container, what does that mean by starting, spinning, or running the container? That means the processes inside the container starts the execution. So once you execute the Docker start command, your container is up and running. Instead of going in two-step process, first create and then start, rather than that, you can execute a single command called as Docker run that would create and even start the container. And as soon as you execute the Docker run command, container goes to running state. If I want to stop my running container, it is like a graceful stop I want to do, then I can execute the Docker stop command with the container ID or container name, and Docker container moves into the stop state. You can go ahead and remove the container completely from this Docker host's memory by doing a Docker RM, and Docker RM would delete the container. So stopping the container means the container is not running but existing in that system. You can find that container in an exited state, but once you do a Docker RM, it gets deleted and it's no more there in the system. Okay. But if I have stopped the container and I want to come back to the running state, then start command can be executed. So Docker start and give the container ID. It will bring back the container process to the running state. You can even pause the process which are running inside the container by executing Docker pause command. And difference between stop and pause is when you are saying stop, the container processes are completely killed and container moves to exit state. When you say pause, processes are still there, but they are not utilizing or they are not executing any of the processes at that point in time. They are just on hold. So once you pause that, the container moves to pause state. And in case you want to unpause that back, you can type in Docker unpause command. So this way you can go ahead back to running state. I can even go to deleted state from created itself. I created a container, but I didn't want to run it. Then I can go ahead and delete the container using Docker RM command as well. So these are few of the states in which you can run your containers. It would be executing in one of the either states. Let's see some of the basic commands with which you can create a container. So Docker run creates and executes the container both. You can create a container in an interactive fashion. -I and T means -I is for interactive and T is for the TTY. As soon as you do a Docker run -IT and specify the image. So here Ubuntu is the name of the image and bash is the process with which you're starting the container. So it will create Ubuntu container and start a bash process inside it. And because we have mentioned -IT, it will interactively take me inside the container's prompt. So as soon as you execute this command, you would land into the terminal inside the container. Let me do that for you and show it. So Docker, I'll just clear the screen. So Docker run -IT, I'm giving Ubuntu image and I'm saying bash process. And if you see, we are not dealing with images. We would do that in the next section. So just for now, skip what is the image which is coming. Just understand it is picking up the Ubuntu operating system template and then spinning up this container. And if you see, you are inside the container's terminal, and root is the user with which you have started the container, and this is the container ID. Actually, this ID is pretty huge, but here it just lists the starting 12 digits of the container ID. Okay, so we are inside the container's terminal, and you can see by typing in PS, bash is the primary process which we started during the container creation. That is the primary process which is running inside this container. In case you want to exit from this container, because we have gone inside the container in an interactive fashion, and you want to exit from the container and you don't want to stop it, you can press Ctrl P and Ctrl Q in sequence and come back to your virtual machine's terminal. So if you press Ctrl P, Ctrl Q in sequence, that time you would be exiting from the container's primary process and coming back to your virtual machine's terminal. How to list if the container is up and running? You can do Docker PS, and here you can see this is the container ID, the image with which your container has pinned up, the command which you executed, when was it created, what is its state, and the name of the container. Because we didn't specify hyphen name during the creation of container, it has automatically given itself a name. The container is named by the Docker daemon. So this way you can create container in an interactive fashion. Whenever you are saying interactive, you interactively land inside the container's terminal. The other way of creating is in the detached mode. That means as a background process. And in that case, you would not be landing inside the Docker's terminal, the container's terminal. Rather, container would get created, but you are still on the virtual machine's prompt. So the option would be Docker run. -D stands for the detached and the TTY, and Ubuntu bash is the image and the process with which you are starting. So let's execute that as well. Docker run -DT, and I'm giving Ubuntu, and I'm giving bash as the process to start. Container has started, and this is the complete container ID. And I can list the running containers with Docker PS command, and you see now I have 2 containers up and running. Here it just lists the starting digits, but actually the container ID is such a huge one to get that uniqueness. And here also it has named the container by itself, and both looks very alike, but here we didn't land into the terminal of the container because we started it as a background process. Here we had started it as a foreground process. We logged in inside the container's terminal as soon as the container was created. That's the difference between these 2 commands. We listed all the containers which were running with Docker PS command. In case few containers are in stopped state or paused state, you can do Docker PS-A and list all other containers as well, which are present in this Docker host. Suppose I go ahead and I do a Docker stop on one of the containers. Let me stop a container. Command to stop would be Docker stop with container ID. And this time if I do Docker PS, it would just list one container because PS lists all running container. If you give -A, that means --all, list all containers, you can find your first container which is there, it shows up and running, and the container which we have stopped, that is showing as exited. So this particular container is now exited. The processes are not running, but the container is still there in the memory. You can quickly go to cd var lib docker, and you can see these containers are listed. So here you should have containers. I'll just go inside that and do an ls. You have those two specific containers. You can see that even the IDs are matching. Here FF7E and 6605 is the container details. So whatever containers, whichever containers you're creating, everything gets listed over here, and these are all container related files which we are retaining over here at this point. Same way, if you have the images created, because we downloaded the Docker image, we should have one of the images over here as well, but images are maintained in layers, so we would have the layer database having lot of layers which was related to the image of Ubuntu. So we would be seeing these images in the next section. For now, let's work with containers, and hopefully we have learned how to create a container now. So when we want to list the processes which are running inside the container, because we understood that when a container is created, it is actually going on the Linux kernel level and spinning up a process. So somewhere we should be able to visualize or see the process which is running, right? So when we do Docker PS, and we can even go and grep for all the processes which are running connected to the Docker daemon. So Docker PS command would show the running containers, and if I execute ps-fxa, this is for listing the processes which are running, and I'm grepping for all Docker related processes. You would find multiple sections populated here like this. So let me quickly show you that particular command, ps-fxa, and I'm grepping for Docker. I'd say grep Docker, and I want to list at least 3 statements for each of the sections. Then I have written -83. If you see, this is one section and this is the other Docker daemon which is actually running. So this is the section for another one container which is up and running. If you see, we have just one container up and running. I'll do Docker PS. I just have one container. Let me start the other container which had exited. So what I would do, I would go ahead and do Docker start with the container ID and verify if the container is up and running. Yes, it is up and running. Now let me dump this command and show you that it would have multiple sections like this. We had understood that each time the container gets created, there is a container shim process which is running and the bash process which is running. In case bash, whatever primary process you started inside the container, that should be up and running, right? So here, if you see, bash and this shim is one section from here to here. This is the shim's process ID, and this is bash process ID which is running inside the container, and this is the second container's shim ID, and this is the second container's bash process ID, and this is the process ID for actual Docker daemon which is up and running. I can go ahead and kill my containers by just killing the bash process as well. So we will discuss about the primary and the secondary processes going ahead. Let's list few of more of the commands which we can work with containers. If I want to remove the container completely from Docker's memory, then I will do Docker rm with the container ID. And if my container is already up and running, but I'm not connected to it, like how we had started that container in detached mode, it is running in detached mode and you just want to connect to that container, then you can do a Docker attach with the container ID and get into the container. But you can only attach to the process which provides you a terminal, like the bash type of process or a shell type of process. Another way to connect to the container is to do a Docker exec. Exec stands for execute. You can execute a command by connecting to that container using Docker exec command. There is a difference between how we attach using Docker attach statement to a running container or how we connect to a running container with Docker exec. We would see that in our demo. So let me clean the screen and let me execute this Docker PS command. these two containers are up and running, but I'm not connected to that container. I'm not inside the container's terminal at this point in time, right? So what we would do, if I want to connect to that container with docker attach command, I would execute docker attach and I'll give the container ID. So here, this is the container ID. And if you see, as soon as I did docker attach, I have gone inside the container's terminal. I can come out from that by doing just Control-C, and I'll just do a docker ps over here. I would connect to the container with docker exec command. So let me do a docker exec and show you the difference. If I do docker exec -it, and if I give the container ID, let me give the other container ID. I can connect to the same container as well, but I'm just connecting to a different container. And here, if you do ps, you would see this bash process has a different process ID. This bash process is not the same bash process. I'm opening a new bash terminal in the same running container. So what happens? I was running a container with one process inside. So I started a container over here on the Docker host, and bash was the process which was running. Let me reduce the size of the brush, and this is the primary process which is running, okay, inside the container. So this process is up and running, then the container is up. If the primary process is killed, the container gets killed. So if you do a docker run command and you enter inside the container with -it, say Ubuntu with bash, and this becomes the primary process. So what we did, we pressed Control-P and Control-Q to come out of this terminal, the root terminal of the container ID. We did this. In case we would have typed exit, it would have killed this bash terminal, and because it was the primary process, this container would have moved to exited state, and that is the reason we did Control-P plus Control-Q instead of typing exit. Same way, when you do docker attach and you give this container ID now, the same container ID, you connect to already running process. You are not creating any new process. You're just connecting to the already running process, and you're connecting here to the same primary process, the bash process. And you go to the bash prompt, and this is the same bash process which you have started, you have connected to. So in case you type exit, because this is the primary process to which you have connected, again the container would die. So to be on the safer side, what we would do, in case I am running a primary process, still then if I want to do any debugging and all, instead of connecting to the primary process, you would always execute using a secondary process. I will give the container ID and I'll give a bash. This time this bash and the primary bash is different. I'm saying execute interactively in this container, the bash process. So what would happen? You will again log in and you would land inside the bash process. You are into the bash terminal, but if you do ps, you would find this bash process ID is not 1. It is having some other number like 8 or 9. But this bash process ID is always 1. Always the primary process has process ID 1. And secondary processes have some other process ID number. Okay, so this process is secondary process. So if you type in exit on this terminal at this point in time, you would exit and you will come back to the virtual machine's terminal and your container would be up and running as well. So what we learned from this, that in case you want to start a process, which is the actual intention of starting the container, you start that container with the primary process of that. That should be the primary process. Like for example, I want to create a web server container, then web server's daemon, whatever is there, let it be Nginx or HTTP or any Apache web server, that should run as the primary process inside the container, and you can run any other secondary process like bash and connect to the container and execute commands in that. Hopefully this is clear. We will discuss about Docker images. So images are the templates with which we start our containers. So image is like a file that would be executed inside the container once the container is up and running. And the most important part, how we have a template for a virtual machine and you can't modify the template, same way the image with which the container starts is the read-only part. It is a read-only template, and containers can't make changes to the images with which it starts up. They are built from the instructions for a complete executable version of an application. What does that mean? To prepare an image, you can execute multiple instructions, and once the complete set of instructions are executed, the application container can be spinned up from them. And images are maintained as multiple layers in the union file system so that we can save a lot of memory, the space needed in the system to save those images. So we would go into the image layer, the read-only part and all a bit more in detail. And the image with which the container starts, it always addressed as base image. So you would say in our example, when we started the container with an Ubuntu image, Ubuntu was the base image for our container. And using the Docker run command, we can create a container from a given image. And if I have a running container, I can do a Docker commit and I can create image from a running container as well. So let's understand how the image layers are maintained. The Docker image actually consists of multiple layers. It is built on one top of the other, and it is maintained by union file system. So image would be saved in the local machine with the help of union file system to maintain it. And the images are immutable. So any image you take, you can't make changes to that image. If you want to make changes to that image, you will have to spin a container from that image, and then you have to make the changes to any of the files which sits in the template. Then you copy that to the writable layer inside the container and you make the changes. So here, as it says, the Docker image is immutable, and when changed, it normally adds a new layer, which is the writable layer of the container on the top of that image. An image would be shared across containers. We would see that how with a single Ubuntu image, you can run multiple containers of that. Okay. And just to reiterate, containers memory is of two parts. One is the image, which is the read-only one. And the dedicated memory of the container is only the top layer, which is the writable layer. So if you have a template like this, which is called as Docker image, I can spin multiple containers from it. And all these containers are referencing the same image and running. Okay, we would see few of the Docker commands. So Docker pull is the command to pull an image from the remote repository or the registry. Docker images lists the set of images which are present in our local server, which is called as local registry. And you can export a command. That means if you want a containers file system as a tar file, you have a container running and you want to export that into a tar file, you can do with Docker export. If you have a tar file prepared and you want to create a image out of it, then you can do the import command. And RMI is the command. How we had Docker RM with the container ID, Docker RMI stands for remove image. We can go ahead and delete the image from our local registry using Docker RMI. So if you see this, in this particular pictorial representation, it shows that my image is constituting of multiple layers. Even the read-only part, okay, it would be made up of multiple layers. What's the advantage of this? I would be explaining it in the next few minutes, but for now, understand this particular read-only image also would have multiple layers, and this read-write layer is the one which belongs to the container. If I have multiple containers running using the same image, each container has its read-write layer and the rest of the stack remains the same. So all the 4 containers here have their dedicated read-write layer, which is a very thin layer, and the read-only part is the common across all the 4 containers. And when you want to make changes, suppose I have a file residing in this layer which has to be changed for first container, it would go with copy on write. That means it will copy that file to the read-write layer and make that changes. And that change will not be visible to any other container because that is in the memory of only this Docker container, the container 1. And this read-write layer is non-persistent, and to make that data persistent each time, whenever you make any significant changes, you will have to commit and you prepare a new image out of it. Okay, so let me explain you all those things from the command line place. So I'll just clear my screen, and I have a Docker image over here, if you see, which is Ubuntu latest. And if you do a Docker PS, I have 2 containers running from that particular image. 2 containers are referencing to the same Ubuntu image. And if you want to see what layers the Ubuntu image is made up of, you can do Docker inspect. Inspect is a command with which you can inspect any of the resources. I want to inspect an image now, so I can pick up the image name with the tag, or I can pick up the image ID. So if you see here at the bottommost part in the root file system, its type is layered way of saving it, and these are the 4 layers our Ubuntu latest version is made up of. And if you just closely see through this command output, it gives you the tag of this particular image. It gives the complete ID of this image, and it is a SHA value. When we say it is a SHA value, that means SHA is an algorithm which helps us generate this unique ID each time. Okay, so we are generating unique IDs for images, unique ID for containers, unique ID for the layers. Then all of this are actually used to generate. We are using the SHA algorithm. Okay, and here if you see, there's no parent of this particular image. This image is the standard basic first image which can be created. I can create many more images out of this, right? So when I commit on top of it and I create a new image, that time this image would become the parent of the other image. And if you see over here, it gives when it was created, and it also gives it was created on 17th June 2020, if I'm not wrong, and this was the container which was running, in which we have committed and created this image. And it gives few other more details about it, what command would run in case you start the container. So if you see here, it's the bash which would be executed. And here if you see, it gives the Docker version on which it was created, plus the architecture of the operating system details are given. And finally, you have the layered, all the layers listed over here. So this gives the complete details about the image. So Docker inspect is the command which would provide you the complete details. You can inspect on any type of Docker resources. Now I'll show you how to pull a particular image. So let me pull a Docker image. I would do Docker pull, and I would give, say, Nginx. I'm pulling an Nginx image, and this is connecting to hub.docker.com and pulling that particular image. So how does it work? Let me quickly clean this page and explain you how does the image layering works. So we would be connecting to hub.docker.com. So let me make it like this. It is hub.docker.com, and this is my Docker host machine. So this is Docker host in which Docker is running, the Docker daemon is running, the operating system is there. And in this system, in the file system of this machine, we are using the union file system, and we would be saving the images. So first time when you do a Docker pull, what happens? First, I'll just give you an example of Docker pull Ubuntu latest. Okay, if you don't specify the tag, it goes and fetches the latest. Think that this is a blank machine. Till now, no containers are there, nothing. It is a fresh machine which we have. No images, no containers. So once you execute this command is taken by the REST API, the CLI, and it is handed over to our Docker daemon. Docker daemon, because this manages the life cycle of image, it goes and looks for the image in the local file system. So this is addressed as local, my bad, the spelling is wrong. 1 second, let me delete this. Yep. And it is addressed as local file system. So let me write that, local registry, this file system. And this is addressed as remote. So the remote server is addressed as remote registry, and the local one is addressed as local registry. And in this registry, you can create private repo or you can create a public repo. So what we are doing, we are downloading things from the public repository. We will discuss about the private repo in our next video. Now think, because we haven't created any hub.docker.com credentials, we are connecting to the public repository of hub.docker.com, and we would be downloading images from there. So Docker daemon goes and checks, no images present. So it immediately connects to hub.docker.com and pulls the image. So when this pulling of image happened, we got 4 layers. I'm just noting down the layers over here. 1, 2, 3, and 4. But if you do Docker images, what it says. So here a database is also maintained like Ubuntu:/latest is made up of layer 1, 2, 3, and 4. Okay, so this is the layers which are being referenced when you say I want to create a container with Ubuntu latest. Now the image is being pulled. I want to start a container. So what would happen? I'm starting my first container with -dt command, and I'm giving -- name as C1, and I say Ubuntu:/latest and I say bash. So this would be my first container. Let me start my container 1 over here. So this is the first container. Container memory would be like this. This is the read-only part, which is actually not present with the container. Rather, it is referencing these layers and spinning up. And the other part is the read-write part, which is the thin layer for this particular container. And this is our container 1. Now, if I want to spin up container 2, then I would do exactly the same, and I'll just say container 2, and I'm using same image to spin up my container 2. So let me bring up container 2. Container 2 over here would have again the read-only part, which is referencing over here all the layers, and the read-write layer for this container, and this is container 2. So here, if you see, all the 4 layers are referenced inside both the containers. And if you try deleting this image, it would say that containers are there, which is using this particular image, and you can't go ahead and delete this image. So here images, this is the read-only file system, okay? You can just reference and spin your container, and you can share across containers, but you can't make changes to them. Now, for example, think in container 2, you went and did apt update. Okay, what would happen? Obviously, a delta is being downloaded when we are updating. Some update to any of the packages would have happened. So out of these 4 layers, something would have got updated, and that is present in the read-write memory of this particular container. And this is non-persistent. That means if I delete my container now, this update, whatever has come, that will go off. If I have to start, again, I have to start with Ubuntu latest image and again do apt update. Instead of doing that, what we would do, we would execute the third command, which is called as docker commit. And I'm saying docker commit with container 2, and I'm giving the name. I'm saying Ubuntu:new. Okay, so what would happen? This layer, which is the non-persistent read-write layer, now gets written inside the memory. So this would be now committed inside the memory, and it is making layer 5. And there is a new entry in the database called as Ubuntu:new, which would be 1 + 2 + 3 + 4 + 5. Okay, and this is the delta layer. So now imagine you are starting third container, say docker run, and you want to do it dt, and you're giving name as C3, and you're saying Ubuntu:new and bash. Okay, so because I am picking up this image, what would happen? I'm creating a container called as C3. In the read-only layer, you will have 5 layers. 1, 2, 3, 4, 5. Everything referenced from here. So what it does, as soon as you give this command, it goes to the Docker daemon. Docker daemon goes and checks this particular database. It understands, okay, Ubuntu:new is made up of these 5 layers. It picks all of them which are needed and starts this container by referencing them. These are just references, okay? It's not present in this memory. It's all reference. The read-only part is actually not there. It is present here and referenced from here. And the read-write layer comes empty. If you want to do any installation, if you want to do any changes, you do it in this layer, and again you commit it. A new layer would get committed, and you want to spin a container from there, then again that referencing happens. So this shows few things. Important stuffs, I'll just highlight it with a different color. The registry server from which we are downloading, that is addressed as remote registry. The local copy of it which is saved, that is called as local registry. It uses union file system to have this layer management done. And whenever we are doing the pull command, it goes and checks, the Docker daemon goes and checks in the local. In case it is not there in the local, then it goes and fetches from the public repository of hub.docker.com, and it downloads all the layers. And it also maintains like a tiny database where it understands this image, which layers, this image, which layers type of thing. And your container's memory is actually having the read-write layer, which is non-persistent. And in case this gets deleted, this data would be lost, which is present over here, right? And read-only part is just the symbolic links or references, which are referencing these layers which are present in the file system and booting up the containers. So same layers can be referenced across containers. See, I'm running 2 containers. I'm just having a single image or 4 layers. I'm not having 4 layers here, 4 layers here, right? And here in this extra container, I just have an extra layer, nothing else, right? So it is saving a lot of memory because I'm referencing the same layers across multiple containers. And Docker commit is the command to commit and create an image out of a running container. And Docker rmi is the command with which you can delete the images. So if I want to delete image 1 or the Ubuntu new, I would give docker rmi ubuntu new. If no container is running with that particular image, it would be deleted. In case any container is running with that particular image, it would give you an error. Just imagine I deleted this container and I'm saying Ubuntu new, delete this RMI as well. It will just go ahead and delete this delta layer. These 4 layers are used in Ubuntu latest as well. That is the reason it will not get deleted. It will give you a feeling that it deleted everything. It deletes this entry. It deletes the only delta layer and it retains all these 4 layers because that is shared by other images as well. So images are also sharing layers. Images are shared by containers, and containers memory is just ephemeral or non-persistent memory. To retain that contents, we have to commit and prepare a new layer in the file system so that it is retained and can be used further. And read-only part is the template part, immutable part. You can't make changes to it.
And we are going to look at containers and images hands-on lab. So I'm continuing from the previous lesson where we earlier looked at how to install and configure Docker container on an Ubuntu machine. So let me explain. We just briefly looked at some thing on containers, but let me explain here and we'll continue from the previous session. So just to explain, first of all, when you have already installed a Docker host, which was an Ubuntu machine that you did on Azure machine, and on that you installed the Docker software using apt update, and that's what we got from Daemon. And with that, you also got client. You can have client externally, or when we install Docker software on a Docker machine, which we call it Docker host now. With that, you get both server and client. So from the same machine, we are going to run or fire our commands. So this is where that acting as a client as well as server. So when you create a Docker machine, or when you want to create, when you want to create a Docker container, the first thing you do is you fire this command called docker run at the bottom, last one. And when you do that, it's going to first look at a image from which it needs to create a container and in its local repository. So in that local repository, if it can't find in its local repository, then it's going to go to the remote registry, which is on DockerHub, and pull that image from the DockerHub we call remote registry. So it will connect over the internet and pull that repository, and then bring it and store it in the local repository. And from that local repository, it'll create a container. From here, let's suppose I have a image I picked up onto local repository and then created one container. If I want to create another container of different image, I'll again run second command docker run, and then it will check that image. So by default, let's suppose this image was not there. It'll go and fetch that image, which is of Nginx, and then bring it here onto the local repository, and then create one or more containers. So from the same repository, I can create multiple containers. So in first one, I created one container, and then later I created from the single image, I created 2 containers. So that is in a nutshell about the whole architecture or container image that we are going to look into. So just to do a quick recap, one image, I just need to fire a command called docker container run, and then it will create multiple containers. So if I run it 3 times, it will create 3 instances of containers from the same image. So I'll have 3 different containers running on the same host. So relation image is or using images, you're creating a container, or instance or a running instance is called as container. Whereas when you shut down and you have or the template through which you create containers is called as image. I know I'm repeating myself, but I think just want to recap one final type. You have the template, and using that, you're creating multiple containers from that image. Now let's go and look at the portal where to find out the hands-on lab, and it'll be on the same place where you have downloaded. You probably might have already downloaded the copy on the portal. So this is I'm on the portal, and this is I mentioned earlier, this is the hands-on, this is the theory part where Mamta covered some of the basic concepts about the module 1, and this is associated lab we are doing. So if you have not yet gone through, or you have directly jumped onto this, make sure you in the first lesson I explained about overview or installation options of Docker. Then in the lesson 2, we looked at how to register for a free trial account. Lesson 3, we looked at how to create and configure a Ubuntu machine on Azure cloud. Then if you're a Mac user, then how to connect to this Ubuntu machine from Mac. And then previous lesson, we installed and configured the Ubuntu machine. So then for activity guide, you click on this activity guide here. I've already downloaded, it will download the latest edition. And every time we update the guide, I will put it here. So I've already opened this guide here, and let me go on to top of this. And just to do index on this, we've already done till the chapter 5, which is working with containers. We are going to work now on working with Docker images or containers. I think we should have working with containers. This is what we are going to pick it here. Now, for us, we need to make sure that the machine that we created, we need to start that machine. And if you have not, make sure that every time you are done working on a machine on Azure, you shut it down. So this is my Microsoft Azure account. I've logged in already. Now I'll go to the virtual machines, and virtual machine should be down. So this is my Docker virtual machine. I'll click on this. It's currently in state stopped. So I'll start this. So click on start. And this is again, next time I'm not going to repeat it, but this is how I hope you understand. If I need to stop it, you select this. After once work is done, it'll stop. Once the machine comes up, I'll get a notification here like this and say, right now I'm getting a notification that starting the virtual machine. Once the machine is fully started, it will get a public IP, and then I'll connect it from using here. Now every time, so I've got IP again. So this is where if I'm not retaining the public IP because it charges if I'm retaining it, so I give it back to Azure or Microsoft, and then every time I start, I get a new IP. So I'll be starting a putty session here. My putty session was already closed earlier, so I'll say new session. And because my IP address have changed, so I'll update the IP address here and say save. Let me close this one. One thing I'm not sure if I explained here, click on data and auto login username. I've already entered username as whatever my machine username that I created in one of the previous lessons. So click on open. Because my IP address have changed, it's given me that notifications. I'll say yes. And now I'm on Docker machine. Now let's look at this command, and I'm going to run and explain you all the commands. So let's go straight to the documentation, and I think we'll begin with working with containers. So first thing you look at is you've logged in and you type docker run -it space ubuntu space bash or one of these. So when I say docker run or Docker container run, it's one and the same thing. I'm saying container run, and if you don't specify container, it will automatically knows that it needs to run a container. Now -it means interactive mode, which means it will go to straight inside the container and will give you the command prompt. As you see here, it's inside the command prompt. Earlier I had a different machine name, which is my Docker host, and now I'm inside the container. Now space, and then this Ubuntu means I'm starting this container from a image called Ubuntu. So because first time I've installed, there's no image on my local machine, it's going to fetch the image from the Docker Hub and bring it to my local machine, and then start the Docker container from that, and it'll go straight to the bash. So this is what I'm doing first. And then later, once I'm in this Docker container, so this will spin off the container. I'll go inside the container and I'll go and update my container. So right now I'm not updating here my host or Docker host. I'm in fact updating the container or the operating system or Ubuntu machine or another Ubuntu's machine which is running inside the container. And then I can exit out from this container typing Control P and Control Q. So first Control P and Control Q, then it will come out from this command prompt. If I exit from this, if I type exit or quit from this container, then it will kill the container. So just type Control P and Control Q. So let me first go and show it to you. So I'm on this Docker machine. Let me copy paste these commands. So I'm going to pick up Docker container. So I remember that I'm creating a container, but it's same thing as I said. So type this command, Docker container run. Remember, Ubuntu is a image name. Hit enter. And so if you see unable to find any image locally, so that's why it went pulling it from library. It's going to the Docker Hub. And now There's another thing which you might have learned from the theory part, which Mamta covered, that this image can be consist of multiple layers. So in Ubuntu image, you had a couple of other these different layers, I'm assuming. And then my download is completed. And if you see now, earlier I was on this machine called a Docker machine. Now I'm inside the container here. So if I type host name, I'm now inside the container. My host name is something different now, FDA. This is the container name or the container host. Now I'm going to run this update, which means I'm updating my container operating system or the operating system running on the container. So it will download all the images all the latest update, and it has updated some packages inside the container, but not on my Docker host. So now if I want to come out of this container, I'll say Control P and Control Q. And now if I type host name, and now I'm back on my host we called Docker host on which my container is running. Now, if I want to see the container, what all processes are running, or my container should now be running behind the scene using the image Ubuntu image. So I can either do Docker PS or I can use Docker container ls. It's one of the same thing. So I'll select this and say Docker container ls. And if you notice here, my container is running with, this is my container ID. The image it started was from Ubuntu. It started command bash. It started a minute ago. Status is up for a minute. And port number right now, I've not covered anything port. We have a separate exercise later, a separate dedicated lesson on networking. And this is where we're going to cover a port. And there's also a name of this. We have not given the name. So it randomly picked up name from one of the developers name. It has picked up automatically. So this is my Docker container now up and running. Now, if I want to look at list of all the containers, because I've already just started one container. Now, if I shut down this container, then the ls command will only list me the running containers, whereas ls-a will show me the stopped containers as well. So before I go and look at the local images, let me first stop it and wanted to show you how do I stop the container. So same Docker container stop, though it's not given in. I can either pick couple of names as long as few characters from this ID, or I can do full, or I can do the container name as well. So I can pick any of these to stop it. So now it will stop, and now that means it's stopped. If I do now ls, it will not show me the list container running because it's stopped. But if I do -a, it will give me that this is a stop status, and status is exited, which means it's stopped probably around 3. It was created 3 minutes ago, but currently in a state exited 10 seconds ago. Now let me start it again using the same command which I did earlier. So now I should be having 2 containers. So like Control P and Control Q. Now because I have got 2 containers, because I started 2, so you see here, first one was this one which was stopped, and now I have a second container. Now if I look at the images, so I can run a command called Docker images. That will give me the image from which, or image that being pulled up locally. So if we see, now this is the image Ubuntu which I got it, and it was created 5 days ago on the DockerHub. I bought it just now. The tag is latest, and this is my image ID. Now next is, if I want to pull just a Docker image alone, like I'm not creating a container, but I just want to pull an image from the Docker repository or DockerHub, and the image name is Alpine, and it's 3.6 version. So I can pull this image. So I'm going to select this now here. And right now I'm not creating a container. I've just pulled an image from, so it says pull complete. And this is my digest, which is like a hashed value, which is encrypted value, so that it gives me a unique number, which means if anything changes, the number will change. So that means basically the authenticity or the content are not tampered. This is exactly what it should match one on the server. I'll cover that about digest a little bit later. You don't need to worry about that for the timing. So now if I see my list again, if I do my list again, Docker images, I now have 2 images, Ubuntu and Alpine here. So this was created 16 months ago, and the tag is 3.6, image ID is this number, and it's size 4 MB. So the Alpine, the leanest, or I say the smallest operating system on which you can deploy some other applications. So this just 4 MB. whereas Ubuntu we saw was 73 MB as you see as from an image point of view. Now I can then list the image. So rather than listing all, I can just simply say directly uh, give the image name. It'll give me, rather than listing me all the images, just give me Alpine because that's what I'm interested in. I can also do the full listing, which means it will also show me the image ID in a SHA SHA format or SHA basically encryption method. So if I see no truncate, it'll give me full image ID with the SHA value as well of this. Now, if I want, I can also use some filters. So let's suppose I have a lot of list of images. Right now, we just have 2 or 3, but you might have 100, 200 images and you want to search, you can do a filter as well. So I'm doing here in a filter and referencing any list down only the image which has a filter or which has a name Alpine. So I type that, I'm running and I got the value here. So this is basically, different options to list down my images which are deployed on the server. Now, if I want to see what is inside that image, probably I can run a command called inspect. Inspect will tell me what all things are inside the image. So if I type here and say inspect the Alpine image that I downloaded. So if you see here on top, it says that first of all, the ID SHA ID of this so that I can compare the SHA ID with on the Docker Hub, just if I'm worried about if it's being compromised or tampered with. Now, tags applied is 3.6. What I'm interested more is about here, which is the layers. So as I said, as Mamta mentioned earlier, that the image is nothing but collection of one or more layers. In this particular Alpine, there's only one layer because it's the smallest one or the very basic minimal operating system. Now let me see if I have other images and I want to do this now. Inspect of other image of type Ubuntu. So let me do, instead of, I'll type Ubuntu inspect and then do latest. If you see now here, it has 4 layers, 1, 2, 3, 4. So Ubuntu has consist of 4 layers now here. Now this is under working directory. So my layers, all these are directories under where lib docker overlay. And this is where I have images. There are other things as well, like we'll cover that maybe later, but the most important thing I wanted to show you was that it consists of layers. Images consist of layers. Now, what you can do is from a running container, you can create an image as well. So let's suppose I want to see if my Docker, any process is running. So Docker PS, that will give me the list of any running container. So I have a running container, which is this, and I want to create an image. That's what I'm doing here. So I'm saying Docker commit. This is my Docker ID. So it should be different for you. In my case, it's 9BAA. So I'll say here Docker commit. And then my Docker ID is this here. And you don't need full, you just need some few characters which are unique on list of running processes. And then I want to create a image. So out of a running container, I'm creating a image. So my image name new will be Ubuntu :new or tag new Ubuntu. Now, if I want to see list of Docker images again now, I should have probably 3 images now. So first one was I created Ubuntu latest, and then I downloaded Alpine. The Ubuntu latest came when I created my container first time of type Ubuntu. Then I manually pulled Alpine, and this is where I got created just 10 seconds ago by committing my running container. So container, because I updated the container with new updates, and now or when I did apt update in the first section, which downloaded some additional packages RPMs inside the container, I've now created an image. So now this new image will have Ubuntu new will also have those RPMs which got updated in one of my previous commands. So now I want to list my containers again here. So I say Docker PS. So this is I now currently have a Ubuntu, this old one. If I want to start another Ubuntu container from this new image, I can spin off, I can fire off the way I did it. Instead of this time I'm going to use tag as new. So Ubuntu :new to start if I want to start a new image. Now that is all about images. So another thing which Mamtam also mentioned, that from a running container, you can create a tar file. Right now we have created an image. Instead of creating image, you can also create a tar file. And what scenario you might use tar file is, for example, for you to share images, you need to push it into the Docker Hub or your private registry where other user but then can pull it. But let's suppose you don't have a image repository, and right now you just want to complete a zip of that through which your developer can then create, or your administrator can create a image file. That's what we are doing here. We are creating a tar file from a running container, and from that tar file we'll create a image. So let me first see my running instance, running container. Instead of BC3538, I have a running container which is 9BA. So I'll see here, type here Docker export, and now my container is 9B something, and then I'll say here ubuntu.tar. And I think I might already have a Ubuntu. I might have already done on the server, but let me try out one more time. So if I do now ls-ltr, I did ubuntu.tar, which is, I'm recording it on 12th of July, early morning. So that's why you see the timestamp. Let me remove the other ones just so that it doesn't confuse you, because I'm going to use these a little bit later. So now I got the ubuntu.tar, which I created just now. So now I want to create from this tar file. Let's suppose I've shipped it to someone else and they want to create a image from this. So I can import the tar file into an image. That's what I'm saying. So I'm saying Docker import and dash my Ubuntu. This is my this Ubuntu is my image name, my Ubuntu, and I'm creating it from the tar file. So I'll simply say this. Now this has already created my Ubuntu image. And if I want to see Docker images, and I got one more image called my Ubuntu here. And this time I have not exported or I've not pulled this image my Ubuntu from DockerHub. I in fact created it from the tar file. That tar file was created from a running container. So hope you understand this creation of image from a tar file. Now, what if, let's suppose I don't have a container. I want to pull an image and create a tar file from that. So other option is you have an image which is running on a repository, or not running, but that is inside a public registry or Docker Hub. So I have this image which is Nginx. I'll pull this first of all from the Docker Hub. So if I run this, it's going to now download all the layers of this Nginx, and I've now got this image. So if I Docker images, I also got this Nginx here. This is the one which I've just downloaded from Docker Hub. Now what I'm trying to do is I want to save this image as a tar file. I've got this image. I want to ship this image to someone else, but they can't accept it as an image file. They can only accept it tar file, just for example, because tar get a single zip version. So how do I do it? I'll say Docker save -o and then my Nginx one dot. So this way what I'm doing is I'm creating a tar file from an image that I just pulled it from Docker Hub. And now again, you don't probably you may not need these, but this is just comes handy if some other person wants an image from you, but they can't accept it in image format. They want to do it on tar format. So if I now do ls-ltr on this folder, I've got this tar file, my nginx one.tar, which I can ship it or zip it, or sorry, it's already zipped. I can send it via email, put it in a folder, drive, or somewhere. So this is where I got my tar file now. I can also remove the images from my local repository. So how do I remove? So I first, let's suppose these are my images and I want to remove, here I'm removing Nginx now. So I can say Docker RMI. Docker RMI is remove image. So I'll type Docker RMI and I can either use the image ID or I can use repository name here. And it has deleted all the layers on that. And if I do ls list now image, and I now don't have that Nginx because I've just now deleted that Nginx. Now if I have two Nginx with the same name or repository name, then I have to select tag, or I can directly go and remove using the image ID as well. So this was the command we used to delete it, which was so Docker RMI Nginx. This was the command we used to delete it. Now I want to, so I've deleted the image, but I want to bring that image back from my tar file. So I already created a tar file and I want to now bring it back from bring that or create that image from the tar file that I created earlier, the same Nginx image. So let me see. First of all, there's no Nginx here. And now I'm saying load an image, but this time from the tar file that I already created in past. So now it's importing, unzipping this tar file and then creating images. I got my Nginx image back here. So if you see now, back latest, which was created 35 hours ago. And now I can do list down my image, which is Nginx. It's already available. I've already seen that. So this is my Nginx image, or the same image, which I've got it here. Okay, so just to continue, or before I continue further, what we did till now was we pulled the images from the Docker registry. And now in this section, we are going to we'll push our image, we'll create an image and push it into the Docker repository. So what I've done is, first of all, if you should not, or you may not have an account, so you go to hub.docker.com and sign up and create your ID. You need to enter your name and email address and register for this on the Docker Hub, because we're going to create or push our repository into that Hub account, the account that you have created. So I've already created in hub.docker.com, I've already created an account with the K21Academy and I've logged into that. And I've already published or pushed to our repositories already. So I might use a different name in this particular case, but make sure you go here and create an account here. Once you have created the account, it's quite simple, straightforward. Then first, in order for us to push an image to Docker Hub, we need to first tag it. And before we tag it, we'll be logging in from our machine, or the machine where I want to push it. That machine, I'll first log in to the Docker. So I have here Docker login, and because I've already logged in here, probably maybe not prompt me for this. Yeah, so I've already logged in and hence it's not prompting me for login ID, but otherwise in your case, it will prompt you for user ID, or to username will be something like whatever username you have created. In the screenshot you see here, it's Mamta J, but in your case, it will be your ID. In my case, it was K21Academy. So make sure you replace this user ID with your user ID and then enter the password. Once your password, it will say that something like this, login successful. Now next is we need to tag an image from using our ID. So in this case, I'm picking up an example Nginx that I'm creating my own tag and pushing it into my repository. So I'll say Docker tag Nginx latest. This is the image which I want to push it. And then I tag it with my ID. In my case, the ID is K21Academy. And then / Nginx latest. This is the name I want to give it. So any private repositories will always have something like whatever user ID. So hit enter, and now I'm going to push it by saying Docker push, and then whatever ID I put it here and click this ID. So I'm pushing it to this, and it knows that now I need to push this in whatever image was this tag into this repository with this name. Hit enter. Now, in my case, it's saying layer already exists because I already have that account. Oh, sorry, I already pushed it earlier. So let me create a next one, another one. But this time I'm going to say Nginx 3 because I've created 1 and 2, I think. So I'll say Nginx 3 and then latest. And now I'm going to push it, same thing, but instead of earlier I had Nginx, normal Nginx, I'll say 3 and hit enter. And now if you see mounted from this, and it has actually this time earlier I got a layer already exists inside the repository, my Docker Hub account. Now it's mounted. And if I now go and look at in my Docker Hub, I should have Nginx 3 as one of the repositories. So if I go here and refresh this page, which is hub.docker.com, I've already logged in, and I should have one more here as Nginx 3. So this is the one which I just now did, which is Nginx 3, which is few seconds ago. So this is how I have loaded now, pushed in private my image into my Docker Hub. So next, probably private registry, we might push it or we might change the order of this guide, and private registry, because private registry needs something called as volumes or storage, which probably we'll cover a little bit later. So next we'll cover networking and then storage, and then this volume or private volume, and then we might move this document or this private registry, Docker private registry a little bit later in the section here. But just to do a quick recap on what we did in the entire activity guide, it might sound a little bit lengthy, but once you do it, it becomes very easy or straightforward. So first is we started the container in the background IT, in interactive mode, and I've spinned off or created a Docker container using Ubuntu image. So I can either use without container or with container command, it's one of the same thing. Then I updated my operating system, Ubuntu operating system running inside the container one. And then I exited by control P and Q, and I was able to see the process, which is Docker container ls, to see my container as running. Then we looked at images. Because I created a container, it pulled that image from the Docker Hub and created that image locally on the system. Then I pulled another, this time instead of creating a container which pulled the image, I just want to pull an image. I don't want to create a container, so I just want to pull an image. So this, in this case, pull image, and image name is Alpine tag 3.6. Then I see the size is it's a very small, tiny 406. I can do some options to check my listing of my images with no trunk, or I can use a filter. And main is important, inspect. If I inspect Alpine, it has only one layer. Whereas if you inspect Ubuntu, you might see 3 or 4 layers. Then I can create an image from container. So I updated the container earlier with the latest RPM, and then I can create an image out of that, which I did, by creating Ubuntu new. So I was able to see the image. Now I can also create a tar file from a running container. And tar file are handy if I want to share it with others and they don't have repository access. I can put them into a tar file, and from the tar file I can then create a image as well. So I exported a running container into a tar file, and from that tar file I imported and created a image from that tar file. Then other way to do is I can also pull an image from the Docker Hub and then create a tar file from that image. Or then later I deleted this image. This is just to experiment and just to show you different things on having a different ways, the same image in a different way, image file or tar file. So there I deleted this image, and then I created the image from the tar file that I created earlier. So by running Docker load, and I got my Nginx image back. I also created an account in Docker Hub and pushed my personal image into my personal account, in my case K21Academy, and I was able to see that placed in the Docker Hub. So this is all covers everything related to Docker and containers.
We would be discussing about the different types of Docker networking. So Docker networking has been a pluggable type of subsystem, and there are different sorts of drivers which can be used to set up the networking across containers on the Docker host. And how can we find what all drivers are supported? You can execute the docker info command on your Docker host, and in the plugin section you can see there are different types of plugins which are supported for this type of this particular version of Docker. So here you see bridge, host, IPVLAN, MAC-VLAN, null, and overlay type of network, right? So we would be seeing few of these type of networks. By default, as soon as you create Docker host machine and you install Docker on that, there are 3 network which gets automatically created. One is the bridge type of network, second is the host, and third is the none type of network. So bridge network is the default network driver which is chosen in case you don't specify any parameter while creating a container. You don't mention which network you want that container to get created in, then it takes the default network. The host type of network is in when the container replicates the complete host's network stack and starts behaving as if it's the host itself. So whatever would be the IP address of the host, that would be the IP address of the container in case of host networking. And the third one is the none type of networking, in which the container's complete networking is disabled. It can't communicate to any container on that host. By default, if we are thinking of a Docker machine, and till now we are confined on a single server, right? We have a single Docker host and we are creating containers in that. So the ability to communicate across Docker hosts is not there with a simple Docker type of software. For that, you have to take cluster type of software like Docker Swarm or Kubernetes. Then only the containers running on Docker host 1 can communicate to containers running on Docker host 2. So there's a limitation with the Docker that it can't set up inter-host communication. Let's understand how does the communication happen when containers are on the same host. So I can create container. So this is my Docker host machine in which I am running Docker Daemon. Docker software installed, Docker Daemon is up and running. So by default, I have bridge type of network. This is the bridge network which is created by default. And this bridge is actually created on the Linux level. This is a Linux bridge and it is named as Docker 0 on the Linux level. I'll show you all these things on the command line as well. Using the bridge utility commands, we can dump and see that it is actually the Linux bridge which is present, but on the Docker level it is called as default bridge, and on the Linux level the name is called as Docker 0. You can create multiple containers on that bridge. So when this bridge default got created, it has a subnet associated with it. It has a gateway IP address, and from this subnet, this container would get an IP address. Like for example, the IP address would be like this in case you have 172.17.0.0 as the subnet range. And if I create container 2, so this is marked as container 1, and I create container 2, it would take 172.17.0.3. Gateway takes the 0.1 IP address, and from there the next IP addresses are grabbed by the containers launched on this bridge. So what happens? This Docker machine actually has an Ethernet interface marked as eth0. And whenever a packet would come on this, it should fall on the bridge, and from the bridge it will go to the container. But at this point in time, we are not exposing any ports of this container. So we are keeping it simple. We are just thinking of containers communication within that network. We are not going outside the host. So containers on the same bridge can communicate to each other. So you can communicate from C1 to C2 and C2 to C1. That's by default possible. There is no nothing that which we can stop it. So this is an isolated environment. If you see, this is an isolated environment. This bridge is an isolated environment, and how many ever containers I create on the bridge, they would be able to communicate to each other. Okay, and you can create your custom bridges as well. So let me pick up a different color, and I am creating a custom bridge called as custom bridge itself. The name is custom bridge. So let me name it as custom bridge, and I create containers on this custom bridge. Then what would happen? These containers, let me name it as C3 and C4. Even though they are on a different bridges, on one Docker host, the container name and the container ID will be unique. You can't say that I'm creating container on a different bridge, so it will be again named as C1 and C2. It can't be possible. In one Docker host, all the containers should have a unique name. So this is the custom bridge, and you can define a subnet like this for it, and let this container get assigned with, it should be 18.0.2 and 172.18.0.3 as the IP addresses. These two containers can talk, but communication across networks is not there, because when you want to communicate from one bridge to the other bridge, you need a gateway bridge type of thing, which is not there with default Docker installation. So inter-bridge communication is not possible in case of simple Docker software which we have. And we will see when we go to Kubernetes level how these things can be resolved. This is a limitation on the Docker level, right? And one more thing we need to understand, the ingress and the egress traffic. So we will talk about egress traffic. We talk about the ingress traffic once we expose a port and we want to communicate outside. That time we will discuss about it. Now understand that if a container is created, by default the egress is enabled and it can communicate outside the network. So this is by default enabled type of thing. From my container, if I want to reach outside, I should be able to reach without doing anything. There is no changes needed. It takes the ETH and it goes out. So we will see all these things. We would be able to ping across containers. We would be able to ping google.com once our container is up and running. And we would see that this communication is not possible, but the communication within containers on the same bridge, that is pretty possible. Okay, so let's quickly run through our slide. We will see the bridge type of network. And in this bridge type of network, we can create an isolated environment for a set of network which want to communicate with each other, and communication outside the bridge to any of the containers is not possible. It is completely isolated for that particular bridge. We cannot modify any of the settings for the default bridge because it is already created with the Docker daemon when the installation is done. And if you want any different IP address range for your container, you want to customize anything, you can rather create a custom network. So in this picture, you would see that I have depicted a custom bridge called as my bridge, and there are two containers running on that, which is like the DB and the web. So DB has got .2 IP address, web has got .3 IP address, and they both are hosted on the bridge network called as bridge, and that falls down to this Ethernet interface, which is the 𝐿0 interface of this server. So let's quickly see how do we work with the bridges and the containers. So because we will have to see whether the bridge name is Docker 0, what all bridges are there, we would quickly install. I'll just do an apt-get update on this server. Let me do sudo apt-get update with a Y, with a -y, so that it doesn't ask. Okay, there's a typo. There has to be a P. My bad. Yeah. So let this update, and then I would install with apt install command. I would install a utility using which I can run some bridge-based commands called as bridge utils. So this will help us execute bridge-related commands like brctl show. This would list all the bridges in this network, in this Docker host. If you see, there is a bridge created called as Docker 0, and this is the bridge ID. So let me clear the screen and show you the IP address. IP address, the short form can be this IPA, and with this you would see that Docker 0 is there and 𝐿0 is also present. So 𝐿0 is the default interface, the first interface of the Docker host machine. Our Docker server is having only one Ethernet interface card, and that is assigned the 𝐿0. And Docker 0 is the bridge which is by default created. Okay, so let's create a container, and we would not specify any -- network option, so that should get created on the default bridge. So I'll quickly do a docker run -dt. I'll give Ubuntu and I'll give a bash. So let me do this. So it's created. Let me check Docker PS. Yes, it's up and running. So let me quickly show you that on the bridge there would be a new Ethernet interface created. How our virtual machine has a default Ethernet interface, same way container also would have an Ethernet interface, and that gets listed over here. This is the container's Ethernet interface. Container is also serving like a server, right? So container, you can imagine that is like a server, and it has an IP address associated to this Ethernet interface. Let's find out what is the IP address of this particular container. For that, you will have to do a docker inspect, and you will have to give the network ID. Let me pick the network ID from here. And if you see here, the container section is there. Let me quickly show you from the top. It says bridge type of network. This is the ID. The driver is bridge. And here, if you see, there is a container section. And in this bridge, how many ever containers are spun up, they would be getting listed here. So we have just executed one container is running, and that container gets listed over here. If you see the IP address associated with that container is this. So my container's IP address is 172.17.0.2 at this point in time. Okay, so if I create one more container, let me create one more container quickly and verify with Docker PS command, and I should be able to see there is one more Ethernet interface. So on this Docker bridge, there are multiple Ethernet interfaces listed. And if I go and do an inspect on the bridge, I should see two containers now, one with the .2 IP address and one with the .3 IP address. So there are two different containers running on the same bridge, and they have two different Ethernet interface, their respective Ethernet interface and IP addresses attached to that Ethernet interface. Okay, so let me quickly get inside one of the containers using a docker exec command, or even you can do docker attach because you have created with bash as well. Let me pick the container ID. Let me take .31 and I'll say bash. So I should be inside the container. I don't have by default the ping utility. So let me do an apt-get update and install iputils command ping to package so that I am able to ping to outside world or to the neighbor container which is running on the same network. So I have updated. Let me do an installation of the package. So for Ubuntu, the ping utility is in iputils-ping package. Let me say yes, and it has downloaded. Let me show that by default egress is allowed and I should be able to ping to google.com. This is one thing. Plus I should be able to ping to the other container which is running on the same bridge. Okay, so I should be able to ping to .2 from here. Cool. And if you can see the IP address inside this container, you will have to install ifconfig if I can run, or ipconfig if I can run. Let me check. No, these utilities are not there in the bare system, the bare operating system which we have picked up. We just installed the ping utility so we could be able to ping. So this particular exercise showed us that you are able to ping from this container to outside world, which is by the google.com ping, and we are able to ping to the neighboring container running on the same bridge. Let me exit, and there are two containers running on the same bridge we saw with the docker inspect command, right? And I was able to ping from this container to this container. I'll leave this containers running, and we would see the custom bridge creation, and then we would see how do we work with it. So let me create a custom bridge. So docker network create is the command for the creation of any network, and let me name it as custom_bridge, and I'm not specifying any the subnet range and all that. Then it picks up some default values and it automatically assigns the details to it. So let me do docker network ls to list the bridges and the other networks. So here if you see, this bridge network which we have created is getting listed, and if you do a brctl show command, you should have one more bridge now, and this is the bridge name. If you say it has taken br and it has taken the bridge id and given it a unique name, and if you create containers on this bridge, then you would have interfaces created on that and IP addresses assigned from this bridge to those containers. Let's quickly do that. So whatever command you executed for creation of container, you would just give -- network, one more parameter to it, and say -- network and give the name of the bridge or the ID of the bridge, anything would do. So with this, the container is created. And let me do docker ps. Yes, it is up. Let me create one more container so that I can show you that within the custom bridge also the containers can connect to each other, but from custom bridge to the default bridge, when I try connecting, it's not possible. So I have totally 4 containers running now, 2 on the default bridge and 2 new ones on the custom bridge. Let's quickly inspect our custom bridge and see the container IP addresses. If you see, there are 2 containers running, one with .2 and one with .2 and one with .3 IP address, and one with .2 and one with .3 type of IP address. Let me quickly get into one of the containers. Let me pick the container ID. Yes, and I would say bash, and I am into this container. So I am into .3 container at this point in time. I've picked up this container ID. I'm inside .3 container. Let me quickly install ping utility to see whether I am able to ping. So first I'll do an update, and then I'll do apt install. Sorry, there's a typo. Install iputils -ping, and I can give -y here itself so that it doesn't prompt for yes and no. Okay, cool. It has done the installation of the package ping utility. Let me ping google.com. Yes, even on the custom bridge, the egress is by default allowed. Let me ping the container on the same bridge. 172.18.0.2 is the other container. It's able to ping the container on the same bridge. Let me ping the container on the default bridge. And you would not be able to ping because bridge to bridge communication can't be established. Default Docker software, the Docker, it doesn't have the provision of establishing a gateway bridge. When bridge and bridge communication has to set up, there should be a gateway bridge between them, and that's no provision for any gateway bridge. So this shows that we can create custom bridge, plus we can communicate across bridges. Communication is not possible, but within the same bridge, multiple containers can talk to each other. So bridge is actually establishing an isolated environment, and containers on that bridge gets the IP address on that particular subnet range. Quickly, I'll exit from here and do a brctl show command and show you that there are 2 different Ethernet interfaces on this bridge network as well now. So 2 containers running on the custom bridge, 2 containers running on the default bridge.
We are going to look at labs for networking. So we'll first create a custom network of type bridge. So we already will see that also the list of networks being available here. So before I start, I need to go to my Azure portal and start the virtual machine that I created, because every time I work or finish work, I stop my Azure machine to make or save money. So this is my Azure portal. I was earlier on home. I click on virtual machine, and then this was my machine. It's currently stopped. I click on that and say start my machine. I'll pause this recording for a few minutes. Once the machine is up, I should be able to connect or find out where the IP address, public IP, or I'll click on connect and say I want to do SSH connection. And right now machine is down, so I think it's already given me the IP. Let me connect to this. I'll start putty. Previous session disconnected, so I'll say new session. This was the machine which I saved and say load. IP has changed because every time I'm stopping this machine, I'm saying I don't want to retain my public IP because it charges for that public IP otherwise. I save new connection, I'll say open, and I get that alert because it's a new IP being assigned to this machine. I say enter my password, and now I'm on my Docker host. So I come straight to the chapter where we say networking, and we'll look at Docker bridge networking. And first command, we need to look at what all networks are available on the server. So listing the type of networks available on server. So I'm connected to this machine here, and I'll say Docker network ls. So right click on this Docker network ls. So I have this bridge, host, and none. These 3 type of drivers I have: bridge, host, and network, these three networks. Now I'm going to inspect the bridge type network. So this is my default bridge type network. These three networks are automatically created as soon as I install Docker. So now if you see, if I inspect on this, so bridge type, and what it's saying is that when it was created, which is 18th of July, I created and installed a new Docker machine today. So that's why you see being created. Driver is bridge. And what's important is that the subnet automatically assigned subnet CIDR 172.17.00.16. So if whenever I create a new container from this Docker install, and if I don't specify any network driver, it will assign automatically a bridge, and it will attach this container to this default bridge network, and it will assign IP from this subnet, which is range, which is 172.17.0. It will start from 2. So 0 is and 1 are reserved, and it will begin with 2. So 2, first container you create, it will create 2. Second container you create and leave it to the default network bridge or default bridge network type. Then you will get next one, 2, 3, 4, and so on. So this is the subnet that we get. So we got. Now, if I want to see what all plugins are this Docker support, so I'll say Docker info and what all different network driver type it supports. So if you notice, the different network type are bridge, host, IPVLAN, MACVLAN, and null and overlay. And bridge and host are most common, and we'll see these today or in this episode. And then overlay is used for multi-host. So if you have Docker running on multiple hosts, you can connect overlay, but for that you need Docker Swarm. And we're going to look at these multi-host connectivity on Kubernetes. So we'll not focus on overlay here. We'll look in Kubernetes, how do you connect multiple hosts. So these are the two different network bridges you have available, or network devices. Now let's see, let's stop first all the containers, if any container running. So if I do Docker PS, I have that Docker running. So I'll say Docker container stop, and then we'll put this, I'll stop the container. And now I want to see, next what we need to do is I need to install the utility. This is I'm installing on Ubuntu machine at an operating system level or Docker host. Bridge util that will give me utility brcatl. So that I can see what all bridge network interface card I have on the Linux machine. So I'll say install. It'll download the package. So already there. So it's nothing no new, which is fine. Now I'll see brctl show, and it will show me the information about bridge. So if you see, there is only one bridge network, which is of Docker 0. That's the default one you get. And currently there is no interface running on this. Now if I look at IP space A, and that will give me all the IP addresses running on this host. So this is my loopback. This is my Ethernet 0 on this machine, which is basically I'm connecting it via this IP. That IP has a private IP address, and that also has a mapping to public IP at a Azure level. This is what it has created, Docker 0, the Docker host had created, and this is a subnet I got, which means 172.17.0.16 CIDR, which means my 172.17.0.0 and 172.17.0.1 are static, which are reserved. Any new container I get, I'll get it on 2, because I've already started a container. It'll go container on that 2 if I start the container. So I'm going to start the container now. So we'll say Docker start, and in my case container ID will be different. So this was my container ID. So I'll say start this container, and Docker container ls or Docker PS, one and the same thing. I got this Ubuntu, it's running. And if I now do brctl show, I'll see a network interface attached vETH. So this is the Ethernet attached to this Docker Ubuntu machine here. No, not Docker Ubuntu machine. It's assigned to the Docker container with the image Ubuntu. Now, this is where I'm going to look at inspect the bridge. So I'm saying Docker network. I'm typing command network, and I'm inspecting the bridge type of network to show you what all things I see here. So if you see here, the ID of this bridge this is the ID. It was created on 18th of July. That's when I'm recording this session, or I've installed this. driver is bridge. What's important to here is this is the subnet range assigned to this bridge network. So whatever machine or containers I create within this bridge, default bridge network, I'll get IP from 172.17.0.2 and onwards, because 0 and 1, this last digit 0 and 1 are reserved by the container itself or network itself. Now, on this bridge network, I'm running a container 57C355. This is my same container which I started above 573C5. This is the one which I started just now. Now, on that, I got an IP address. This Docker container now has IP 172.17.0.2. This is the IP address of this container, which is installed on this network. So if I want to ping this, so I'll say ping, and this is in my case IP address is this for the container, and I'll be able to ping this from the host. So I'm connected on host, I'm pinging my container. If I do 3, because there's no container on this 3, it will not ping here right now. But if I start another container, then it'll get a IP address 3. If you see now it's saying host unreachable, it'll get 3 IP, and then I'll be able to ping it. So let me do one more. Let's run one more container and exit from there, control P, Q. And now if I now do brctl show, it'll tell me the 2 interfaces, because I have 2 containers running, and first one is for the first one and this is for the second container. Now if I do the inspect this network now or bridge, I should have 2 containers now listed here. So if you see, the subnet is static because this is a subnet for the entire bridge network, but now instead of containers, instead of 1, I have 2 containers. One is this container whose IP is 3. This is the new container we created. Old one was 57C. I have 2 IP address. So if I now able to do the ping on earlier, ping was not working for me for 3. Now I should ping or able to get a response. Now it's getting a response from 3. Now what I can do is I can see now these 2, because these 2 containers are connected to the same bridge network. They should be able to talk to each other. So I'm now attaching my connection to this one of the containers. So I'll say Docker attach, and I'll go and attach myself to maybe the 3 IP or which one IP. It doesn't matter. I'm connecting to the second IP one. So let's connect to this IP second 57C and hit enter. Now I'm inside this container. What I'm going to do is I'm updating the operating system, all the packages inside the container. So I'm in as a root, and I'm updating all the packages because I want to do the actual ping utility. So I want to bring ping on this, because by default on that image ping is not enabled. So I'll bring ping now so that I can ping my other machine. Do you want to continue? Say yes. I'm getting now ping utility. Now from ping, I'll try from this machine host IP. I'm going to do ping a IPA. So IP is not installed. I need to install some more packages in order to get this output of this command. However, because I've installed the ping package above, I should be able to ping this second machine, which is on second container, which is listening on IP3 from the IP address. IP address for this host or container host is 2. I should be anyway able to ping it because it's the same host. But the second container is listening on IP address 3, so I am able to ping that machine. From here, I can even go out. We saw Mamta mentioned that from a container you can go out. If you need to come in, there'll be a different process. We'll do that -p. Maybe she covered when she was talking about the storage. That time she mentioned you need to use p publish for ingress, incoming traffic. But right now, if I want to go to Google, which is I'm going egress, which means I'm going out, I should be able to ping it without any problem, because it's checking the DNS. Again, we looked into the DNS. So it picked up this etc, I think it's resolve.conf. It picked up resolve.conf from my host of or Docker host, which is Ubuntu machine. I'll show you in a minute. And that's why it was able to resolve google.com, and it was taking the same route as Docker host route. So the container will connect to the Docker host, and eth0 running on the Docker host will take that connection out, and that's why we are able to ping Google here. Now, if we go, so this is pretty much about the network bridge.
we would discuss about host networking. So in host networking, the complete network stack of the host gets replicated inside the container. So containers network stack is not isolated from the host. Rather, it starts behaving as if the container itself is the host. Okay, so it doesn't have its own IP address allocated. Rather, if you see in this particular example, the host IP address is 192.168.0.1, and that becomes the IP address of this container. What advantage are we getting out of this? In case we want to optimize the performance, we would be able to process the packet much more quickly, because here, if you see, this is the public IP address, and even this is the public IP address which is there. And when you want to handle a large range of ports, like I don't want any NATing happening, network address translation, then I can go with such type of network. Okay, and this does not require the NAT translation, as I mentioned. So let's see how do we work with it. Let me first explain you in the pictorial representation how different it is from the normal bridge type of network. So this is my Docker host, and it has Docker daemon running. This is my Ethernet interface, and this Ethernet interface is having a public IP address. This is the IP address of my Azure VM, right? And if I create containers on the Linux bridge, on this bridge, any type of bridge, right? Whether it be a custom bridge or the default bridge, if I've created container 1 gets the IP address in this particular subnet range. And we had seen that it got an IP address of this. And if I want to reach from outside, then the connectivity is a bit different, right? So here, if I have to send packet to this container is not reachable from outside. That is the difference, and I will have to reach the Docker host first at this IP address, and then from here fall to the bridge, and from the bridge it has to go to the container. But if it falls to this bridge should be in a position to understand to which container it has to send, because it would be having a lot of containers running on that bridge, right? So we would see this external connectivity in further examples. But in this video, we are more interested with host type of networking. So I am creating a container. There is no bridge like this. I'm directly creating a container. I'm denoting it with a square box, and I'm saying it as C2. And this is on -- network called as host. When I create, I specify the parameter this way. So what happens? The IP address of this container becomes the Azure VM, same as the Azure VM's IP address. And that is the reason it says it replicates the network stack of the host. And if you reach the host, that means you're reaching this container automatically. There is no falling on the bridge and translating from the public IP address to the private IP address, which happens in case of the bridge. That is not there. Rather, this IP address is the same. So if I'm running any application like Nginx over here, and I say I'm listening on port number 80, then you can reach this application directly on Azure VM's public IP address with :80. When you do that, you actually reach directly to this container. Advantage if I don't want to do the public IP to the private IP translation, because obviously there would be a latency in this translation happening. And example, like I used to work on a telecom project, right? I was working with big telecom providers, and we normally make video conferencing calls or any phone calls, and we don't want any latency to be there in those calls, right? So if we fall like this in such type of application, there would be a huge latency. So what we do, we create containers directly on the host network, and we can use this. There is advantage to this. We are optimizing the performance. That is the advantage. There is disadvantage associated as well. The disadvantage would be that your container is completely exposed to the outside world. Whoever can reach your Azure VM can reach your container now. Can I spin multiple containers on the host network? Yes, you can. Here also you specify network is a hyphen network is host, and I'm spinning up container 3, and I can listen on a different port. I can't listen on port 80. I will have to listen on a different port because this port number 80 actually gets allocated on the host machine, right? So 2 container listening on the same port will not be allowed. So I can reach container 3 with Azure Virtual Machines IP address with port number 80, and I can reach container 2 with Azure Virtual Machines port number 80. So we will quickly do this exercise and see how do we spin up the stuffs. So I am on my Docker host, and let's check if we have the default host type of network. Yes, it is present. Let's quickly create a container on that network, and you would give -d, you will give -network with host. This is the parameter you specify, and let me name the container as my_nginx. Okay, and I'll give the image name as nginx. So I'm picking up nginx image and I'm spinning up a container, and I would be naming the container here with --name. I am naming the container actually. So with this, I can spin a container. Let me do a Docker PS and see whether the container is up and running. Awesome, this container is up and running. And how can I reach this container? I'll have to pick my IP address of my Azure virtual machine and go on port number 80, and then I can be able to reach this particular container. Let's quickly do that. This is my Azure virtual machine's IP address, and for port number 80, normally you don't have to specify. By default, it takes the port number 80, and you see this welcome to nginx is serving, and that is not serving on this host at this point in time, right? That is serving from this container. Hope this is clear. And we would stop the nginx container which we have started, so that in the further exercises it doesn't cause any impact, and stop this, otherwise the port 80 would showing up busy and you can't use that port 80 with any other container going further in further exercises. So please remember to stop your container before continuing with the next exercise. We would discuss about the Mac VLAN type of network. This is another type of driver plugin which can be used to establish networking for the containers. And Mac VLAN is normally used when you want to directly connect to the physical network. So in this as well, you would see there are 2 different VLANs on to which my host is connected, and it has 2 different Ethernet interface phases with respect to those Mac VLAN. So ETH0 is now divided, having 2 portions, one for the Mac VLAN 10 and other for the Mac VLAN 20. And one belongs to this green VLAN and the other belongs to this blue VLAN. And if I want to create a container on the DB container on one of the VLANs, if you see the IP address is 192.168.10.2, that comes from this IP address range, and web has got the IP address from the blue VLAN's IP address range. So instead of having the basic networking, if we are taking Mac VLAN type of addressing or the networking, we assign a MAC address to each of the containers virtual interface. How we had the vEth associated with an IP, now you will have a MAC IP address as well. And this also optimizes the performance. It's normally used with legacy application where MAC address is a mandate so that you can talk to those applications. So this was all about the Mac VLAN type of network. Let's quickly run through the basic set of commands. Docker network create is the command to create a network. If a network is present and if I have a container up and running and I want to connect that to a different network, let me show you how we do that. And that time you can give a command called as Docker network connect and connect a container to a different network as well. So let me show you as in pictorial representation what we would do in the demo. So this is my Docker host, the Docker Azure virtual machine, and I have 2 containers, C1 and C2, running on the default bridge network. getting the IP addresses from the bridge. So I'm just marking eth0, and then I have a custom bridge on which I have C3 and C4 running. How our virtual machine can have multiple Ethernet interfaces and have IP addresses associated on that Ethernet interface, same way our containers can have multiple Ethernet interfaces. At this point in time, we just have the eth0, and the IP address of eth0 is having the IP address of this particular subnet on which we have created the container. Like the eth0's IP address belongs to this custom bridge subnet, and for container 2, the eth0's IP address belongs to this default bridge subnet. Let me show you if we want to create one more Ethernet interface, and I will say that this particular container C3 wants to connect to the default bridge, then it will get an IP address from this NAT. So here, if you say Docker network connect, I'm just writing in the short form. If you say Docker network connect, and if you give the bridge and the container ID as C3, it will automatically get an IP address allocated in this range and an Ethernet interface. In the last exercise, we saw that from C2 to C3 communication was not there because they were on two different bridges. But on this IP address, like it had got 0.2 IP address, this has got 0.3. I'll write the complete so that there's no confusion. Okay, so here it would get 172.17.0.4, and for this Ethernet interface, the IP address would be 172.18.0.2, and this container has 18.0.3. So if I want to communicate via this IP address to these two containers, I should be able to communicate. This communication is possible. But if I try to reach on this IP address, that communication is not at all possible. So let's quickly connect to the network and show you. Let me first confirm what all containers are running in this machine. Awesome. There are two containers running on each of the networks actually. Let me quickly do inspect on the bridge. Yeah, so let me pick this container and connect to the custom bridge. Docker network connect. You will give the bridge details to which network details which you want to connect, and you will give the container ID and say done. Command is executed, and so quickly the Ethernet interface and the IP address is got. So if you want to inspect, we will have to inspect the custom bridge because this container would get listed on the custom bridge as well. So let's quickly see the name of the container and the ID of the container. ID we have seen F6ABB. The name of the container is Pandemic Current. So let's do a custom bridge inspect, and you should have Pandemic Current, and this is the IP address, and this is the IP address, and this is the container ID. So now my same container belongs to two different networks and has two different IP addresses associated of two different networks altogether. So now if I do a brctl show command, you should have 3 Ethernet interface here and 2 Ethernet interface on the default bridge. And the third Ethernet interface is for the same container, which is belonging to 2 different networks at this point in time. So let's run through other commands. In case I want to do a disconnect, I just want to remove that Ethernet interface from a specific network, I can do that. The command is to disconnect from that network. We saw the inspect command, with that you get more details about the network. You saw the ls command, with that you list all the networks. In case there are networks on which containers are not running, not the default ones, the ones which you have created, the custom ones, you can do a network prune and you can remove all unused network. In case your network is used by any of the containers, it will give you an error. It will not allow you to delete those networks. Individual network deletion can be done with Docker network rm command, and prune will only remove the unused type of network.
We're going to look at the custom bridge first, or create another network of type bridge only, but custom one, and then also look at the host type network as well. So let's first see what the guide. I hope you already have done guide and you have done all the previous steps. So what we are doing is we are creating a network, but of type bridge or with driver bridge, and we'll name this network as a custom bridge. So before we go, I was already connected to the previous container. So let me control P and Q. I'm out of this machine. In the previous section, I said, in the Docker host, it copies the result.conf is copied from the Docker host by default. So let's see first if the value matches or if we have changed anything on this here. So if you see the value inside what you see on the Docker container matches with exactly what we have on the host. So it's basically copying the same file from the Docker host onto the container. Now going back to the same original, before we go into further, let me see what network we have. Docker network ls, and I only have these three type of bridge, host and none. Let's create one more type, again bridge only, however with the driver bridge. So if I now do Docker ls, I have one more type bridge, sorry this one, but the name of this is custom bridge. By default, these three came by default. So I'm going to pick the custom bridge. Now, so you might be wondering where I do use none. If you don't want any network, you typically use none. Some application, let's suppose you don't want any connectivity, you want to work inside. Now, don't ask me what is the reason for that, but there is an option for you. So there is Docker network ls. We saw that it has created a network called custom bridge, and then with the driver bridge. Now I'm going to create another container of Ubuntu base image but this time I'm instead of using the default network which is a bridge, I'm going to give my own or tell it this container saying use this custom bridge that I created or network created custom bridge. So I've run it in detached mode, and now let me create one more container because we want these two containers. So earlier were the default bridge. Now this time custom bridge, two containers, container 1 and container 2, both with this time custom, and these two machines should be able to talk to each other, but not able to talk to my previous two machines which we created earlier. So now if I see inspect, we inspect the custom bridge, and that now I'll get two IPs like the one which we had previous one. So if you see here, earlier was 172.17 something. Now I got this network has got the subnet of 170.18 instead of 17. So 18, we said 0 and 1 are reserved. 0 is for subnet and 1 is for gateway. So our gateway is basically to go out and go back in. This is the entry point for this subnet. Now in that container, I have custom network or custom bridge network. I have two containers. This one whose IP is 3, 172.18.0.3, and then another one is this container and IP is 172.18.0.2. So what I'm doing now is I'm connecting to first container, and by execute IT, so I'm connecting to first container, and container where the IP address is this one 172.18.0.2, and I'll probably install the same thing which I did earlier in the previous episode or previous video. I updated my IP util ping so that I can ping this from this machine other container which is having the IP address 3 but under the network called custom bridge network. So I'm installing now this ping utility, and it say yes, install the ping. Now I'm going to ping container 2. Now this is now picking up because I can either go directly container name, and this is where it will use internal DNS domain name server to resolve the name to an IP internally within the Docker container. So if I can either ping container name or I can go and ping the IP address. So if you see it's coming, request is coming back from IP. If I go and try to ping the first IP, the IP which we did earlier, and I think let me see what was the IP address earlier. This was the IP address 172.17.0.2 and 0.3. So if we do ping, we won't be able to do as we saw earlier in the theory part, that because these two containers are on a different bridge network. So I won't be able to ping it. Yeah, I hope that makes sense now, what we covered in the theory part. If I want to ping Google, I should be able to ping it because going out will be via the host network, so I can ping it. However, if I want to go and connect with the container running on Docker bridge 0 or Docker 0 bridge, whether it's 2IP or IP address 3, we were running on that network, we were running 2 containers. So I won't be able to ping any of that. So 0, 2 or 3. Whereas these 2 which are running on this bridge, they will be able to ping each other easily. So let me come out of the container. It will not work. Control P and Control Q. So this is how we saw bridge type of network on containers or a Docker, where you have default bridge that gets installed, and the machines that if you don't specify any network, then it will pick up the default bridge. If you type dash network and whatever network we create, which we saw here in network ls, you can assign that network. So if we continue with that, I want to create a host type network. So I'm going to say my host, but then I'm going to use option network, but this time instead of bridge, we'll say host. So option -rm, if you're wondering what is rm, like basically once the Docker container exit, remove that. So I don't want it to be running once I exit, immediately exit. If you're not sure about anything like that, you just say docker help, docker run help, and it'll give you option what is -rm and rm means. So I'm now creating a container, and I'm saying once I exit from this container, delete this container, because I want it to be just for that right now. Run and see and attach the host type of network here. So hit enter, and it's now downloading Nginx, and it will create a container called my-nginx, and on that Nginx it will create network type host. So whatever is the IP address of this Docker host, container will also get that IP address. So if I see Docker PS, I should have the Nginx. I should have 5 containers in fact for now. So 4 were so if you see these 4 Ubuntu's were 2 connected to one network, 2 connected to the other 2 networks. So container CNT con1 and con2 are connected to one network. These other 2 kind Chandrasekhar or determined Harshal, they are connected to the other default Docker 0 container. You remember I told you that these names, container name, are randomly generated in the name of the developers. So this is what I'm interested about. In my case, this is the container which has the host network. So I can then go to the browser of this machine, and then I can open a browser and verify that Nginx is running on that machine. So all I need is an IP address of this machine. This is the IP address, and it's on public. I've already opened port number 80. So make sure you open port number 80 and hit enter. Okay, so this is not working, and the reason being is that if you see under my networking, so I'm connecting to the public IP, and public IP in turn should forward that request to the Docker host. So my machine is definitely listening on 80 port number and it's forwarding request to the server or Docker container. However, if you notice here under networking, so I'm now on my Linux machine on Ubuntu on Azure, and if I go under networking, there is no rule which says that allow port number 80 here. If you see, only 22 port is allowed. So I'm going to add an inbound port, which means incoming request, which says allow connection port number 80 here. So I'll say source any. Port range, I don't want to allow any port range. Source is any, but destination is, instead of 8080, I'll say 80 port number, and protocol is ideally TCP, but any is fine, and a connection is allow. And I add a rule saying that allow port number 80 here. Oh, I should have changed the port name here. Let's see if it let me change. Let me delete it first here and then do a correct name here. So again, add an inbound port and say, instead of 8080, I'm saying allow port 80 and say port 80 and say allow port 80 from internet. And I say add. And let's refresh this and see whether port number 80 is allowed or not. So now port number 80 is allowed from internet, from any protocol, any source, which means any machine, and now it should work here. If I type wget here directly on server will work. So whatever is my IP address for this machine, if you see, I've just done a refresh, it was cached. So now I'm getting a message saying welcome to Nginx. So the reason why I was not able to connect earlier was because the port number 80 was not allowed. The minute I allowed the port number, I'm connected from internet, going from my machine or from my laptop over the internet to the Docker host, in our case, this machine. This machine in turn is accepting request and forwarding it via the host type network onto this Nginx or container, which is listening Nginx, and I'm getting a response back from Nginx. So this is in a nutshell we saw here. If verify the port is bounded, so let's double check this. And if I see it's the port number 80 is bounded by Nginx type, and this container which is listening, so ps-ef and pipe and then grep for 3936, it's actually my Docker container which is listening on this. Now I can stop the container. The minute I stop the container of host Nginx, the port number 80 will Docker container stop host under Nginx. Let me see, there must be a typo somewhere. Docker container, let's see, ls, and it's instead of host Nginx, it's actually my Nginx. So my underscore Nginx. Now it stopped my Nginx. So I've stopped the container and that completes. Now if because I've stopped it, my port number 80 which I was listening, it will not be listening now. And similarly, if I go to the browser, there's nothing listening now in port number 80. And if I go to the browser, I won't be able to see Docker container running. Sorry, not Docker container, but Nginx container server running. If I refresh that, and then say site can't be reached. So that shows the host type of networking in that. So that completes how to configure, create a custom bridge network, and then how to configure or create a container but use host network instead of bridge network.
We would discuss about Docker storage. So by default, all the files which are created inside the container, let's do apt update inside the container, or let's vim and create a file inside the container, everything gets stored on the writable layer of the container. And that data doesn't persist beyond the container's life cycle. That means you stop the container and the data is lost. For that reason, to persist the data which is there on the writable layer, we normally commit a container and we prepare an image out of it. So the writable layer which is present in the container is tightly coupled with the host machine where the container is running. Once the container is stopped, the data would be deleted. It's not something which is given as a persistent type of storage, right? So when the data persistency is needed in container, we would try mounting different type of volumes or the drives inside the container so that we can attain that persistency. The first type of mounting is called as bind mount, in which you have a path on the Docker host, the file system path on the Docker host, like a directory on the Docker host, which would be mounted inside the container. So here it shows all the three types, but we are focused on bind mount now. I have a container. I want to mount a directory which is present in the file system in the LO area of this particular host. This file system would be managed by the Docker host. Anyone who has accessibility to this Docker host can go ahead and delete this directory as well, right? So you are creating a directory on this file system in this Docker host and you're mounting that directory inside the container, then such type of mount is called as bind mount. What advantage do you get out of that? if I have multiple containers running and I want to have the same data inside every container, I need not have data present in every container. Rather, I can keep it outside and I can make changes over here. If I make changes over here in the directory which is present on the host, it would reflect automatically in all the containers without having to rebuild the container as well. So let's understand what is the bind mount type. If I have a file or directory present on the host machine and that has to be mounted inside a container, then it is called as bind type of mount. If file or directory is not present, then it would create that and it would mount it inside the container only when you use the -v option. So there are two options, -v and mount option. So with -v option, it creates on demand if it is not present, and it also mounts that particular directory inside the container. In case of -mount option, if you are using, which is an older way of doing, if the directory is not existing, it would not create that particular mount option. So container will not start saying that something is wrong, that particular directory doesn't exist. And you can mount a directory either in the read-only access method or read-write, depending on what actions you want to perform on that particular directory from inside that container. If I want to do a read and a write operation, I will mount it as read-write. In case I want to do only read operation, I'll mount it as read-only. And if I don't specify any access method, by default, it considers that to be a read-write access method. Let's see the commands. If you're creating a container, docker run -d with the name --name dev test, till there it is the name of the container. We are showing the first type of it, which is -mount, and the type is given as bind. You should have a source, the directory, which would be mounted inside the container at a target location. So this is the source. So source here, if you see, we are taking pwd, that means the present working directory /target should be a directory present, and it would be mounted to /app inside the container, and the image used is Nginx latest. In this example, if /target is not present in the present working directory, it will not work. So let's see the other variation of the bind mount. We can use -v option, and we can be free up from the tension that whether the directory is present or not present. Rather, once we give with -v option, if this directory is not present, it will create that and then mount into /app inside the container. And this is how you can specify the read-write access method or read-only access method. And this is the image of that container. So with this, you would be able to create a container and mount these directories inside the container. So let's quickly go to the command line interface and see how do we do this. First, let's create a directory. For the safer side, let me create this so that we see the difference between the volume mount and the bind mount. So I'm creating something called as volume share. Let me use sudo because I'm a ls-lrt. It is there. cd/home, it should be present in /home, ls-lrt. Yes, volume share is created. This is the directory which I would like to mount. So let me create a container with the mount point, and I would be showing the exposing of the container with port number as well, and explain that in the pictorial representation. I'm starting a container with -it, and I'm giving an option called as @:80. I'll explain this in a while. And -v, you give the source. What was the source? Home, volume, and share. And you give a colon over here, and you specify the destination where html, and you give name for the container, say volume sharing. I'm creating first container, so let me name it as 1, and you give the image with which you would start. I'm starting with Ubuntu image, and I'll give bin bash at the end. I should get inside the container because I've started an interactive mode and I've asked for the bash process to start. I'm inside the container. Here, what exactly I'm trying to do? I'm starting with Ubuntu container, but I would love to host a Apache web server inside the container. So let me go ahead and do apt update inside the container and install Apache inside the container as well. Give it -y so that it doesn't ask for the option again. It will take a while to download this package. Meanwhile, let me explain you how does the -p thing works. So we had seen here we didn't give any -- network option. So this container would get created on the default Linux bridge. My Docker host has the Ethernet interface as eth0, and this would have the Azure Virtual Machine's public IP address is the IP address of this. And there is a default bridge, the bridge type of network, which is there by default. And I'm spinning up a container called as wall sharing 1 over here, correct? And I have mentioned -p80:80 there while creating the container. This is the host port I'm talking about, and this is the container port I have specified. So I am expecting this application, like Apache application, obviously expects packet on port number 80. So my container port is 80, and I would tie to one of the ports on the host. Why I would do that? Because I want the incoming traffic to come. Outgoing traffic, the egress traffic is anyways flowing by default, right? But the incoming traffic is not there yet. So if a packet arrives on Azure Virtual Machine's IP address at port number 80, it will fall to the bridge, and from bridge it will understand, because we have created container by specifying this, as soon as this statement or the command execution happened, in this Docker host, the IP table rule is updated. So it is done with Docker daemon, goes and connects to the kernel and gets this IP table updated. And it mentions that the packet will fall to the bridge, and from that bridge, it will go to the container's IP address on the port number 80. So with this, anytime whenever packet arrives on port number 80, it would be routed to this particular container, which is a volume sharing container one, right? So it goes to this particular container on port number 80. So this port number is fixed because application expects packet on whichever port number that you would be assigning. This port number, the host port number, can vary. If no other container is using host port 80, you can use that particular port number. In case some other container is using host port 80, you would not be allowed. As soon as you execute the Docker run command, it will say port number 80 is in use. So remember, on this host, on the port range, there is only one port number 80, and that can be tied up to only one container. One port number 80 can't be tied up to multiple containers, right? Just imagine if it could have tied up to multiple container, how will it decide that this is the container which I have to send the packet to, right? If it receives multiple types of packet, it can't segregate those packet across containers. So each host port number gets tied up to a container port number. But if I have two containers, like I'm serving, this particular Apache web server is serving ola.com, and I have another Apache web server serving amazon.com. Okay, this is amazon.com website. Because it is Apache web server, this is also listening on port number 80, but I can't tie the two virtual machines IP port 80. So in this case, what I would do, I would mention here -p81:80. Why that so? Because 81 is a empty port on this host and 80 is already booked. So whenever packet comes on Azure Virtual Machine's IP address with port number 81, it will fall to the bridge, and it understands it has to send to the container which is running Amazon's website, and it is listening on port number 80. So whenever we are creating container, the IP table rules modification happens, and that is being done by the Docker daemon. It takes the role of talking to the kernel and getting this update done. It doesn't have the ability to go and update, so it will go via the Linux kernel and update the IP table rule. And this way, the outgoing thing is set up and packet goes out of the system, and when this particular container sends, it will go to the port number 81, it will go out. So like this, on the same host, when there are multiple containers which need external connectivity, you can tie them to unique port numbers on the host and expose them outside the particular Docker host. So we would see this exercise. So I'll just type in any of the area, geographical area and all. It will take a while for the installation to happen. Almost done. I'll install Vim as well because I have to modify one of the files. So I'll do apt install Vim with an -y. I have to edit the index.html web page. So I'll do that. So let me quickly Vim the file which is being mounted at where www.html. Okay, so here where www.html was the path which was mounted inside the container, and that was the file, the directory which was created. So I'll go and change the welcome page. It's on line number 198, so you can say :198 and directly go to the line. And I want to change this default page, so press I for insert, and you can go to the end of the line and delete the strings which you don't want to show up, and here I'll just give the volume sharing 1. So it's like a welcome page from the volume sharing 1 container. I'll just say escape. It takes me to the non-insert mode, :WQ and exclamation, and the file is saved. W is for write and Q is for quit. So I have made the changes to that container's default web page, and now my container is up and running. I should be able to reach this website, but I'll do Control-PQ. And because we are talking about the volume mounting, at this point in time, whatever I wrote in where www.html in index.html, that actually wrote it in volume share. If you go to volume share and you do ls, you should have an index.html, and that should be the same index.html file which we have edited inside our container. So we feel we are writing inside the container, but it's not that case. It is actually writing to the drive or the directory which is mounted inside the container. Let me quickly spin up another container and mount the same drive. So the directory, sorry, not the drive, the directory. So here I'll just change the name, and I'll change the port number because 2 different Apache web servers running can't expose the same port number, right? So I'll make this as 81 and I'll start. And at this point in time, there is no Apache in it. So how we did an apt install Apache, apt update, we would do all those steps, but we would not write the content inside the index.html. Index.html is being served from outside the container from the mounted directory. Okay, so let's do apt install Apache 2 with a Y. We will have to start the Apache web servers in both the containers. I have not started in the first container as well. I'm just picking up the default one value, and I have not specified the correct location and all at this point in time. So yes, it is done. Let me not install anything. Rather, I'll say Apache service start, right? That particular command has to be executed so that I will start my Apache web servers. Okay, so service Apache 2 start. It will give a message. Never mind, it's not an error. You can always go ahead and check the status, and it is up and running. At this point in time, Apache web service is running only in the second container. It is not running in the first container. Let me do Control-PQ and come out and do a Docker PS. You have 2 containers running. One is volume sharing 1 and one is volume sharing 2. One is listening on port number 80 on the host. The other is listening on the port number 81 on the host. And in one container we have started Apache, in the other we haven't. So let me do a Docker exec-it, enter inside this container and start the Apache web service. Service Apache 2 status. It's not running. So in case your web server is not up and running, see whether the container is up. If container is up, go ahead and see inside the container whether Apache Web Service is running or not. In case it is not running, start it. And I can type exit because I have gone with an exec command. And let's do Docker PS and see. Yes, both the containers are up and both are actually serving the same web page. And if I try to reach the IP address of the virtual machine with port number 80, it will show up the same web page, and with port number 81, even though I'm routed to the other container, it will show me the same web page. Let me quickly do that for you. Let me open an incognito window and let me quickly log into my portal and grab my IP address of the virtual machine. Here, I have the IP address over here. Let me quickly go to this and go with port number 80. Yes, this is showing up the cached one. Let me open this in an incognito window because it should not show up the Nginx container. In case you face the same issue, I have stopped the Nginx container, so it can't show up the Nginx container. It has to show the Apache web page in both. In case it is showing the Nginx container, which was from the last exercise, you can understand that even though the container is stopped and that's showing, that means it's the cached one. So always try and open that in an incognito window. If you see, this is the .80 and this is .81, and both are serving the same web page. Why? Because both had mounted. If you go back to your command with which you started your container, so let me do a history and show you both the commands. In both the containers, when you started, you mounted the same directory. In this, because it was mounted as read-write, you could create a file, and that actually created on this directory. And we saw that that file is present in this directory, right? And we did a cat on that index.html as well. And that index.html is serving for the second container as well. And that is the reason whatever changes we made on the first container, it's actually reflecting on the second container as well. If I make any changes now over here on page number 98, and I'll say it's read-only file. Yep, let me quit and open it with a sudo because I am Docker user and I don't have Ubuntu user doesn't have this right. So I'll just do this and I will save. Once I do this, the content inside both the containers would have reflected. Let's go back to our web page and just do a refresh on that. You see this? It is reflecting. It should reflect in both the containers. So now the changes are not tied up with the container's lifecycle. The file is also not tied up with the container's lifecycle. Neither I have to rebuild the containers if I'm planning to make any changes. I've completely detached the index.html file from the container's lifecycle. We discuss about Docker temp-fs type of mounting and the Docker volume mount. So we saw about the bind mount, and the second type of mount which we can have is the temporary file system mount. So in that Docker hosts temporary memory, which we have the memory, in that you can create a space which can be mounted inside the container, and that is called as the temporary mount. And this is also not persistent. Then you would say, already we have a read-write layer which is not persistent, then why we go ahead and mount something that is also non-persistent, right? Whatever we are doing on the read-write area, we do those actions or we make those changes only which we want to commit and create a new image out of it. In case something which is very temporary and you don't want that to be retained after the life cycle of the container, that can be saved in the temp-fs mount. So here it can be used by the container during the complete life cycle of the container, and it stores the non-persistent state or sensitive type of information. In case I only need the password in case the container is up and running, and once the container is stopped, I want that to be cleared up, then I would save my password in the temp-fs type of mount. And you can't share. How we were able to share the bind mount across containers, tempfs mount is very dedicated to the container, and once the container is deleted, automatically the tempfs would also get cleaned up and it can't be shared across containers. It is only available with a Docker on Linux type of version. With Windows and all, you don't have this provision. Let's see the command. How can you create the tempfs type of mount? We had understood that -- mount is the option and -v is the option for case of bind type of mount. Here also you have -- mount. You specify the type as tempfs, and here you don't have source because source would be automatically generated. In the memory area, you will grab a space and that would be mounted to /app inside the container. Or else you can use the later version of this, the latest version of this command with -- Instead of providing such a huge string, now they have shortened it with -- and source is not there. You need not specify destination. Whatever is there that's understood, that's a destination. You say /app. So you get a space on the Docker host, which would be mounted inside /app. And you're starting this container with Nginx. The size can be defined as per your need, or else if you don't define any size, then whatever is the memory area size of that particular host, that can be used by the container. You can also specify the mode, in what particular access permissions you want to mount this point inside the container. That can be also specified over here. Let's see the third type of it, which is the varied, most used type of it, which is the Docker volume 1. In Docker volume, the file system, whatever is present in the Docker host, in that area itself, you are creating a dedicated area for the container called as the Docker volume area. You're creating a Docker volume and then you are mounting that volume inside the container. In the bindfs, you created a directory, or with -v option, it created a directory, but it created this directory in the file system area. With the case of Docker volume, it will also create a directory, but that directory would be managed by the Docker daemon. This file system area, the yellow area, was not managed by the Docker daemon. It was managed by the host itself. But I'm specifying in this itself, I grab a space and I'll say this area would be managed by the Docker daemon. When I specify it that way, that means Docker volume or the Docker daemon has complete control on the volume. You can't go ahead and delete the volume if it is mounted inside a container. It will give you an error over there. But if it was a plain directory, in case of bind mount, if someone deletes the directory, then it's gone, right? So let's see what complete details about the Docker volume. It is used for persistency, no doubt in it. And it would be completely managed by Docker, which means the Docker daemon. Like bind mount, it can be mounted simultaneously across containers. And let's see the commands which are associated with it. So you have to first create a volume with Docker volume create. I'm creating a volume named as my volume. And you can create volume with different specifications as well. That is listed over here. Volume create, and you are giving the type you are using, the size you are using, or here there is a device on which you want to create the volume that you can specify. If it's NFS type of server is serving the volume, then you can give the IP address in the read-write access method or read-only access method and mount that volume as well. So there are different ways you would be mounting the volume from different sources. And once this volume is created, you can go ahead and create a container to mount this particular volume, right? So I'm creating a container in the detached mode with this name, and I'm giving -- mount. Source is the name of the volume, and target is the destination directory where you want to mount. And this is the image of the container. And here, if you see, with -v, the volume is present, and here /app is given, and the read-write access method. All three can be given in the same place. If -- mount is there, if volume is not present, it will not create. But if -v you give, this volume is not present from before, then it will create and it will mount it. Let's see on the command line in action, how do we do all these things? So you would first create a Docker volume. So I'll give you a command of Docker volume create, and I'll say volume 1, for example. And I didn't specify anything. You can just do a docker volume ls and list the volume. You can also inspect the volume. It is like any other resource which is present. I already have one more volume called as my volume. You see, there are two different volumes created in this server at this point in time, but you would be creating one in the exercise, so don't get confused by the command output over here. I have created a volume called as volume 1. I'll do docker inspect and I'll give the volume name. Let's do that. And if you see, it shows the path where exactly it has gone and created a directory. So in /var/lib docker, which we had mentioned that's a standard place all the resources get created. You have volumes. Inside that, a volume 1 name of directory is created, and inside that _data. Whatever you write in this place, that would be visible inside the container when you mount this point inside the container. So let's quickly create a container and see the changes are reflecting or not. So I'll do a docker run. Let me do -it and give a volume. The name of the volume, the source should be this, and I'll give colon and I'll say /data inside the container, and I'll give -- name to my container as busybox container or something, because I'll start that with a busybox image. So busybox : latest. Busybox image is not there, so it has downloaded and it has started my container. I'll go to cd/data and there's nothing. Let me echo something and create a file and echo something inside it. So I'll do just echo and hi from container. And I'll put this inside a file called as a.text maybe. So if I do ls, a.text is there. I can cat the content and you can see a.text content is visible, having that content of hi from container, right? So let me press Ctrl+PQ and come out. Okay, I'm out of the container now, and let me do sudo su because I have to go to the /var/lib docker path. So I'll do cd /var/lib docker, and you have volumes. In that you have volume 1, you have _data in that, and let's do ls. You created the file inside the container, but actually that got created on this host machine, and if you see, the content is also reflecting. So whatever you make changes, either you make changes over here, like if I want to make any changes over here, I say hi from container 1 and I save the file. This changes would reflect inside the container as well, right? So let me quickly spin up one more container for you and show that this container is actually able to this volume can be mounted simultaneously across containers. So I'll just quit from the sudo su and I will start another container called as other container, and I use the same mount point. So volume 1, which is present, I am mounting inside another container as well. So let's do that. It will take me inside the container. If I do /data, I should have a.text, and if I see the content, the latest content, hi from container 1 should be listed over here. So this shows that if I have a Docker volume and I want to mount that volume across containers simultaneously, I can do that. And this volume is not tied up with a Docker's lifecycle, and this volume is maintained by Docker, and that is the reason it is created at this particular location.
We are going to look at labs for storage, the volumes or storage. So the volume is like the persistent store, so that when you store the data and if you remove the container, the data inside the volume will still stay intact. So first thing we are doing is we are creating a Docker volume. So continue with following the guide. So first thing is I say Docker volume and then create what name of the volume. So in this case, I'm saying Docker volume, create volume 1. And then I'll say Docker volume ls and it'll give me the listing of volume, which is volume 1. So now I have a volume 1. So now I'm going to inspect the volume which I created by typing volume 1. It will tell me where exactly it's storing this data. So if you see here, my driver is local and then the mount point is this is actually where it's going and storing the data. So currently the directory is running on the same host, and even if I delete the container, let's suppose I connect my container and then write the data into this, I can delete this container and then my data will still be intact on under this location. So, but this directory is managed by root user. You as a Docker user will not have access to, or at least you won't be able to go to this. If I do try to cd on this location, it won't be, I won't have permission on this directory. Now I'm going to create a Docker container and connect to this machine. So what I'm saying is I'm saying start a container, and I'm attaching volume 1 with a directory called data on my container whose name is busybox, and then image type is busybox latest. So I'll simply go and start this container, and now I'm inside the container and if I do hostname should not work, but let's see, hostname command may not be even there. Oh, okay, got it. So this is my container host name on this host. If I go inside this container, cd data and do ls, there's nothing inside this data, or in this ultimately it's coming from here. So then I'll say create a content and say I create a file called vol.txt, and in that I'm loading the data called hi from Docker. Instead of Docker, I'll say, let me say Docker 1. So you understand, because I'm going to then create another Docker container 2, and then container 2 will try to write it here. So I'll say hi from Docker 1 volume.txt. And now if I do ls, it has done a volume.txt, and cat volume.txt is written hi from Docker 1 volume. So I'll say control Q or control P and Q, sorry. And now I'm on this host. If I go and try to look at, sudo su, and I should be able to go inside the directory, and I should have that file that I created earlier in this location. So if I see, I got volume.txt, let's see cat volume.txt, and if you see the data is there, hi from Docker 1 volume. Let me go back, but let me start one more container now, and this time I'll again mount volume 1, same directory data, but this time I'm going to create another container now. So I've got second container. Now if I look at host name, this container will be 7e, and here earlier container was f2. So these are two different containers, and if I do this cat volume.txt, I should have that same data. So instead of, sorry, not volume, I need to go inside the data. This is the directory I mounted, and under there I had that volume.txt. If I see, it says hi from Docker 1. I'm in Docker 2, but I'm getting the same mount which I did earlier. So that completes our lab where we created a volume, and that volume can be mounted on multiple containers. And even if I delete my container, I'll still be able to access, or my data will still be intact, and I can attach it with later other container as well. So if I see Docker ls, Docker container ls, and I'll say Docker container remove or rm, and let me stop these container which was busybox, this one, and as well as these two. So you could, oh, okay, so I can't, because the containers are still running, I can't stop them. So I need to do the force, it will stop and remove these two containers. So if I do now Docker container ls, but those two Docker containers are gone, but the data will still be intact. So if I now go to sudo su minus, and if I go inside the library which I mentioned earlier, it was under this var lab volume 1, and I think inside under that it's a underscore data, and it should still have the data which is volume 1 vol.txt, and I should be able to then mount this data or this volume in any other container. So that's how retain the persistent storage or persistent volume, and that's what persistency means. Persistency means when you when you stop the container and start, data will still be there, but the minute you delete the container, the data inside that will go away. But here in this particular example, we have created additional volume, storage volume, and then attached to that container. So it has retained, even though I've terminated the container, my storage is still valid or stored. And that's the example of retaining or persisting the storage volume because I've created a volume. The data was not stored inside the container.
So we have put down everything about the certification, including the basic concepts that one should know everything like microservices and Docker, networking, storage and app stack in Docker, Kubernetes architecture and installation, security, troubleshooting and high availability, networking, deploying, application stack, and advanced networking. In this 12-week roadmap, we take you from basics to advanced level along with the tips and resources for clearing the certification exam. We also have a separate team working for CV preparation and on-job support. So if you want to become Docker and certified Kubernetes administrator and want to learn right from basics to expert level, then we have a comprehensive step-by-step training for you that includes hands-on labs, including exam preparation, and the most important part, 1 year on-job support. If you are interested in this program, then I would highly recommend you to attend our free class which covers most of the topics like why learn Docker and Kubernetes. And under Docker, you will be learning what is container and Docker, Docker architecture. And under Kubernetes, you will be learning what is Kubernetes, why to use it, Kubernetes architecture and pods, highly available and scalable applications, and many other topics. So if you are interested in attending this free class, you can visit k21academy.com/kubernetes02. You can also find the link in the description.